अभी रेडी? ठीक है, शुड वी स्टार्ट? ओके, गुड। कहाँ तक पहुँचे थे? लास्ट क्लास में कहाँ तक पहुँचे थे आप लोग? हाई एंड लो प्रेशर, है ना? वेरी गुड। सो हाई एंड लो प्रेशर कंडीशंस आर क्लियर एज यू सी ऑन द बोर्ड। यही वाला डायग्राम हम कर रहे थे, राइट? सो आई होप एवरीवन इज क्लियर अबाउट दिस डायग्राम। एनी मेजर डाउट? हाँ, विद रिस्पेक्ट टू दिस डायग्राम कुछ डाउट है तो बताइए। क्लियर है? इतना क्लियर है? वेरी गुड। आपका साथी कहाँ गया? नहीं, पीछे। और साथ में होता था एक और, डिडंट कम? अच्छा, नहीं होता ही नहीं था। मतलब मैं रॉन्ग हूँ या मुझे तो वहां कोई दिखता था यार पहले, एक और आ रहे होगे। हाँ वही तो है, मतलब ऐसा तो नहीं कि मतलब मुझे पिछला 20-25 क्लास से वहां कोई दिख रहा है और आप बोलो सर कोई था ही नहीं, तो मैं तो कल से आना बंद कर दूंगा यहाँ पे। ठीक है, ओके, सो गुड। So high pressure, low pressure, clear? How many types of high pressures we have? High pressure and low pressure conditions. How are they created? Mechanically and thermally. Okay. And do we check the pressures horizontally or vertically or both? We only check the pressures or compare the pressures horizontally or near horizontally. We do not compare vertical pressures. All right. And then what is the rule of the air movement? Horizontally the wind air moves from high to low, and that you call as, क्या बोलते हैं वैसा एयर मूवमेंट को? वैसा एयर मूवमेंट को क्या बोलते हैं? winds. So such air movement are known as wind. And when we see vertical movement of the air, what do we call it? Draft. Draft, vertical movement. और दो टाइप का draft है, up and down. All right. So and then when you see on the surface of the earth and the upper atmosphere, when you try to integrate the whole image, what do you get? That complete cycle. तो इतना क्लियर है सबको? ठीक है। सो अभी तो आप लोग प्रेशर्स का हिसाब से विंड बहा सकते हैं, राइट? ओके, वेरी गुड। सो इफ आई आस्क यू व्हाट डज द प्रेशर डायरेक्शन टेल यू? प्रेशर डायरेक्शन क्या बताता है हमको? लाइक इफ आई से प्रेशर डायरेक्शन फ्रॉम हाई टू लो, राइट, व्हाट डज इट टेल यू? It tell you the wind direction. Based on the pressure direction you can tell the wind direction. ठीक है ना? इतना क्लियर है सबको? So this is called as pressure difference. The difference between high pressure and low pressure, what do we call it as? इसको क्या बोलेंगे? Because high pressure can have a value and the low pressure can also have a value. So for example, in this region, pressure difference will be equal to what? High pressure minus low pressure. High pressure value हमने यहाँ कितना लिखा है? For example, 120, 120 या 1020? ऐसा तो नहीं कि 120 बोलने पे आप 1020 रुपीज निकाल के दे देते हैं। मैंने पिछली क्लास में बोला था ना, कैलकुलेशन पैसा के सेंस में करोगे तो अपने आप बुद्धि ठीक रहता है। तो कितना हो गया प्रेशर डिफरेंस? 10 millibar. So the pressure difference in this case between the location A and B, pressure difference between AB is how much? 10 millibar. Is this clear? And it is in what direction? From B to A. ठीक है? And hence the wind motion should also be from B to A. इतना तो क्लियर हो गया सबको? अब इसका आगे बढ़ जाए। Okay, now let me give you another example and tell me with respect to this. Suppose we have a location A, another location B, and a third location C. And let us say A to B is 100 kilometers and A to C is 200 kilometers. And pressure at A is 1020 millibar, C is 1000 millibar, B is also 1000 millibar. Okay. So what is the pressure difference between AB? AB pressure difference 20 मिलीबार एंड ए बी लिखना चाहिए था, आई थिंक मैंने कुछ गड़बड़ लिख दिया. एंड ए सी, oh sorry, नहीं ठीक था वो. Pressure difference AB and then pressure difference AC. How much is pressure difference AC? 20 millibar. So what should be the wind direction? Wind direction from A to B and A to B and A to C. तो wind direction ऐसा होगा A to B और दूसरा side A to C. And because the pressure difference is same, so you can see the pressure, the winds are blowing. But if I ask you, in the case of AB and AC, will in both the cases the wind speed and wind intensity be same? Yes or no? क्या होना चाहिए? Logic क्या बोलता है? मतलब should it be same or no? First give me that answer. Should the the wind speed and direction be same? Direction तो sorry, did I say direction? ठीक है. So let me say again. Will the wind speed and wind intensity be same? Why? क्या difference है? Distance is different. तो distance से फर्क क्या पड़ता है? What difference will the distance make? हाँ? Intensity किस चीज का? Intensity of? No, don't give me the answer directly. पहला आपको मुझे logical steps बताना है. If the distance is different, what will differ? Pressure will be? हाँ? Rate of decrease in pressure will be? Rate of decrease समझते हो? For A to B and A to C, the pressure is changing. So there will be a rate of change of pressure. है ना? Rate of change of pressure. So rate of change of pressure is same in both the case. If the rate of change is different, what will change? If the rate of change is different, what will change? Velocity. सीधा. अच्छा, what is pressure doing here? Pressure difference से हो क्या रहा है? It is creating some force. The pressure difference is creating some force, you can say. है ना? So that force over a longer distance. So when the pressure difference is changing slowly, the force will also, would have a different value. And if the pressure is changing fast, right? So still the force will change fast. Now how do we understand this? I'll give you another example that might help. See here. For the ones who didn't get. Right. I'll give you an example. So यहाँ पे you can see what is constant क्या है? This pressure difference. ठीक है, तो suppose हम pressure difference की जगह एक height difference का example लेते हैं. ठीक है, and we keep the height difference same. Right, क्योंकि यहाँ पे pressure is the energy source and height के अंदर suppose if you are having a ball to roll. ठीक है, ऐसा दो balls हैं आपके पास and you try to roll it down a slope. दोनों तरफ slope है and you try to put the ball initially at a constant height. जैसा वो ABC का example है, मैं वैसा ही बनाने का कोशिश कर रहा हूँ. Suppose this is the location A, which is slightly higher. So higher height, and then one side you have a location C, and at the same level, you have a location B. Now what is the height difference? Let us say 20. What is the slope length? Let us say यहाँ पे 100 है and this side it is 200, just for the sake of understanding. So we have converted a air pressure condition, for example, into a height example, and in both the cases let the air का जगह हम ball को roll करें, because what will any mass can roll down these two slopes. ठीक है, so if I put two balls, right, ball 1 and ball 2, both of them will come down by the same height. What is the total height it will come down by? 20 meters. Everyone agrees. So both are at the same height. But if I leave the ball 1 and 2, will they move at the same speed? Which one will move slower? So this one will move slower and the other one will move. Why? The height is same. PD to same hai. But the rate of change of what? Slope. है ना? The rate of change of inclination is different. Because of that, the forces on the two will be different. and hence the speeds will be different. सिंपल भाषा में बात करें, है ना, वेलोसिटी में तो फिर बहुत कुछ आ जाएगा, ठीक है. सो वेलोसिटी तो एनीवेज डिफरेंट है, बट यहाँ पे स्पीड भी डिफरेंट होगा, ठीक है. तो स्पीड विल बी डिफरेंट, ठीक है ना. सो सेम वेज इफ यू अप्लाई सेम लॉजिक यहाँ पे, so suppose you put air at A and this side there is decreasing pressure, that side also decreasing pressure, so both the side the air will go like the ball, but in which case the air will go faster? Here it will go faster or slower? AC, slower. So here the air will move slower and this side it will move faster. Now why is it so? Now what you have, that is something that you have to understand here. In this case the energy is in terms of potential energy and the rate of change is in terms of slope gradient. तो यहाँ पे हम इसको क्या बोलते हैं? हाइट ग्रेडियंट. हाइट डिफरेंस एंड हाइट ग्रेडियंट. हाइट डिफरेंस सेम है 20, बट हाइट ग्रेडियंट अलग अलग है. द हाइट चेंजिंग ग्रेडियंट. इन दिस केस द हाइट चेंजिंग ग्रेडियंट इज, ग्रेडियंट का मतलब क्या हुआ? रेट ऑफ चेंज, राइट. सो द रेट ऑफ चेंज ऑफ हाइट हेयर इज स्लो, द रेट ऑफ चेंज ऑफ हाइट इन द अदर केस इज फास्ट. इतना समझ में आ रहा है? रेट ऑफ चेंज ऑफ हाइट मतलब देयर यू कैन सी द हाइट इज चेंजिंग वेरी फास्ट बिकॉज ऑफ द स्लोप. हेयर द हाइट इज चेंजिंग स्लो. सो वेयर द हाइट इज चेंजिंग स्लो द बॉल विल ऑल्सो मूव स्लो. वेयर द हाइट इज चेंजिंग फास्ट द बॉल विल ऑल्सो मूव फास्ट. नाउ द रेट ऑफ चेंज, उसके लिए एक वर्ड है ग्रेडियंट, जो मैंने अभी थोड़ी देर पहले बोला था, राइट. सो लेट मी रिप्लेस. सो वेयर द हाइट ग्रेडियंट इज मोर, हाइट ग्रेडियंट इज मोर मतलब रेट ऑफ चेंज ऑफ हाइट इज मोर, the movement of the ball will be faster, and where the height gradient is less the movement will be. So what does gradient do to movement? Gradient और movement का क्या relation है? The rate of change and the movement, उसका relation क्या है? Direct या inverse? Direct. कैसे? If the gradient is more, movement will be more and intense. More and intense दोनों, मतलब more मतलब speed ज्यादा होगा and intense भी ज्यादा होगा. Do we get it? Now this does not apply only to this. It applies, for example, it applies to potential energy, it applies to electric energy, it also applies to wind pressure energy. ठीक है, सारा मैग्नेटिक एनर्जी सब में ये फोर्स, यही लॉ चलता है. Wherever the gradient is, gradient मतलब rate of change is high, the movement will be, for example, electricity में क्या होता है? जो आपका इलेक्ट्रिक ग्रेडियंट है वो जहां ज्यादा होगा वहां पे करंट ज्यादा तेजी से बहेगा, ठीक है ना. और जहां पे डिफरेंस कम है मतलब ग्रेडियंट कम है वहां पे करंट स्लोली बह रहा होता है, राइट. वैसा ही हाइट में हो गया और वैसा ही विंड में भी है, ठीक है. सो व्हाट इज द रिलेशन हियर? अब यहां पे हम क्या बोलेंगे? दैट प्रेशर डिफरेंस इज सेम, राइट, बट व्हाट इज डिफरेंट? प्रेशर ग्रेडियंट इज डिफरेंट, ठीक है. एंड व्हाट इज ग्रेडियंट? द रेट ऑफ चेंज ऑफ प्रेशर. यहां पे रेट ऑफ चेंज ऑफ प्रेशर हो गया. उस एग्जांपल में रेट ऑफ चेंज ऑफ हाइट था, यहां पे क्या है? रेट ऑफ चेंज ऑफ प्रेशर, ठीक है. क्योंकि यहां तो प्रेशर चेंज हो रहा है ना, जैसा वहां पे 20 मीटर का हाइट चेंज हो रहा था. किसी बॉल को अगर आप माउंटेन स्लोप से गिराएंगे तो यहां पे हाइट चेंज हो रहा है, यहां पे क्या चेंज हो रहा है? प्रेशर चेंज हो रहा है. सो द रेट ऑफ चेंज ऑफ प्रेशर इज व्हाट यू कॉल एज प्रेशर ग्रेडियंट. सो प्रेशर डिफरेंस और प्रेशर ग्रेडियंट में अंतर क्या है? Difference means difference is like this height of 20 meters, ठीक है, and gradient is like the slopiness. Slopy कितना है? Rate of change of height कितना है, ठीक है. So same ways when you talk of pressure difference would be something like 20 millibar, but pressure gradient क्या हो जाएगा? How will you calculate pressure gradient? If I say pressure gradient यहां पे pressure gradient A B, then you have to divide the pressure difference by distance. तो AB का बीच में distance कितना है? AB 100. So the pressure gradient is 0.2 millibar per meter. This is the pressure gradient. Whereas pressure gradient in the case of AC, pressure gradient AC is 20 millibar divided by 200, which is equal to 0.1 millibar per meter, ठीक है. तो दोनों का ग्रेडियंट समझ में आ गया आपको? डिफरेंस दोनों में सेम है, The difference in both the cases is same, but the gradient in both the cases is different. So in which case will I find stronger winds? Where the gradient is higher. So in which case is the gradient higher? So here the wind will be wind strong and fast. Okay, strong winds and fast winds. Whereas where the gradient is less, the wind will be wind slow and weak. ठीक है, अभी is this clear to most of you? तो अगर एक बिल्कुल सिंपल भाषा में, now forget everything that you have done since morning today and just try to focus in simple terms. तो अगर simple terms में बात करें, very simple terms, what should we say? Pressure difference tells you only the, does the pressure difference tell you the speed? हाँ, प्रेशर डिफरेंस से स्पीड पता चलता है? कैसे कैसे पता चलेगा प्रेशर डिफरेंस से स्पीड? ये बताइए. आई एम लिसनिंग, आई एम वेटिंग. अभी तक आपने क्या पढ़ा है सुबह से, मतलब पिछला क्लास में? डिड एट एनी पॉइंट आई से दैट यू कैन फाइंड आउट द स्पीड ऑफ द विंड फ्रॉम द प्रेशर डिफरेंस? हाँ, प्रेशर डिफरेंस क्या बता रहे होती है जैसे? ओनली द डायरेक्शन, कहां पे प्रेशर ज्यादा है कहां पे कम है. तो इस डायग्राम के अंदर स्पीड हमने कहां पढ़ा है? Yes or no? So simply said, pressure difference tells you only the direction of wind. Simple, that's it. उसका सिवाय कुछ नहीं. So if you want to write, I would like you to write this down. ठीक है? So what does the pressure difference tell us? Pressure difference tells us only the wind direction. Pressure difference tells us only the wind direction. Where the wind will flow from? Where the wind will flow from high pressure to low pressure. Next paragraph. So this is the simply said statement. Pressure difference only tells you the wind direction, and wind blows from high pressure to low pressure. Next paragraph. Example लिख लेना है इसका, so that later on you keep this in mind. This is just like the height difference. ठीक है? Height difference, where objects move from which height to which height? More height to lesser height. This is just like height difference, where objects move from more height to lesser height. ठीक है? But height difference does not tell you the speed. ठीक है? What is the example of that? यहाँ पे देखिए. Does the height difference tell you the speed? No. यहाँ पे height तो दोनों balls का same है, 20 मीटर, है ना? But in one case the ball is moving slow, the other case the ball is moving faster. Is this understood? That's why I gave you this example. ठीक है? So height difference only tells you the direction of movement. It does not tell you about the speed of movement. Now what tells you about the speed of movement? The speed and intensity of movement is told to us by rate of change. ठीक है? The rate of change tells us the speed and the force of movement. ठीक है? So the what you call as strength and speed is told to us by the rate of change. अब ये लिखना है. Should we write? Right? So next paragraph. The speed and the strength. The speed and strength of wind movement. Speed and strength of wind movement. Is told to us speed and strength is told to us by the rate of change of pressure. By the rate of change of pressure, and underline rate of change, उसको underline करना है, rate of change of pressure, right? Where higher the rate of change, stronger and faster is the movement. Higher the rate of change, stronger and faster is the movement. Okay. The rate of change is also known as gradient. The rate of change of anything is also known as gradient. Rate of change is also known as gradient. ठीक है? Hence, pressure gradient. Hence, simply said, pressure gradient tell us about the speed and strength of winds. Pressure gradient tell us about the speed and strength of winds. ठीक है? As higher pressure gradient means, as higher pressure gradient means faster and stronger winds. Higher pressure gradient means faster and stronger winds. इस लाइन को अंडरलाइन कर लेना है. Higher pressure gradient means faster and stronger winds. Okay. And if we write the example just for our, अगर आपको नहीं समझ में आया pressure gradient का concept पहले, so the example is this slope gradient. ठीक है? So if you want, you can write that in the next paragraph. For example, higher slope gradient. For example, higher slope gradient can make a ball move faster on the slope. Can make a ball move faster on a slope. And this is the slope gradient diagram. Faster ball moves faster on higher slope gradient and ball moves slower on lesser slope gradient. The ones who want to draw this can draw and keep that so that later on you understand this concept of gradient. This is mostly for people for whom gradient is a new term right now. ठीक है, जिनको gradient word पहले से नहीं पता था. So just for your own understanding, you can draw it and keep it in your copy. So which force determines the speed and strength of wind? Pressure difference or pressure gradient? Pressure gradient, because pressure difference is not a force, it is the energy. ठीक है, एक energy होता है, दूसरा force होता है, right? When that energy is applied, right, in a given direction or over a given thing, that's what you call as a force. जैसा आपका मसल के अंदर क्या है, एनर्जी है, और वही जब आप हैमर उठा के किसी को मारते हैं तो फोर्स बन जाता है, हैमरिंग फोर्स है ना. या आपका हैंड का मोशन किया आपने एनी डायरेक्शन में तो क्या है, फोर्स, राइट? यू आर अप्लाइंग फोर्स बट द एनर्जी इज इन योर मसल. So same ways, pressure difference is like energy and pressure gradient is like force, just to understand. Is this okay? ठीक है. So which is the driving force for winds? Pressure gradient is the driving force of wind, not pressure difference. ठीक है. So you can write that also. Hence we can conclude that pressure gradient is the driving force of winds. Hence we can conclude that pressure gradient is the driving force of winds. ठीक है, all right. Should we move beyond? Now, how do we represent pressure? Yeah. आ रहा है वहीं ले जा रहे हैं, थोड़ा सा जंप नहीं मारना है. मैंने स्टार्ट किया ही था स्टेटमेंट. मैंने हाउ डू यू रिप्रेजेंट क्या प्रेशर, तो किससे करते हैं? ठीक है, तो इसलिए थोड़ा सा मैं कई बार क्लास में बोलता हूं, है ना, थांबा. यस डियर, तो थोड़ा सा हैव पेशेंस. आ रहा है, हाँ जी. किसका डायरेक्शन? प्रेशर ग्रेडियंट का डायरेक्शन समझने का जरूरत नहीं है अभी, आप बस प्रेशर डिफरेंस का डायरेक्शन समझो. प्रेशर डिफरेंस का डायरेक्शन समझ में आ गया? इट इज ऑलवेज फ्रॉम हाई टू लो. सो विंड विल ऑलवेज मूव फ्रॉम high to low. That is one thing. Once you understand that, then the rate of change. At what rate is that difference happening? Come again? If the distance is long, what is pressure difference? Pressure gradient का formula क्या है? Pressure difference divided by distance. वैसे ही calculate किया ना हमने. सो प्रेशर ग्रेडियंट, अच्छा ये भी लिख लो यार, मतलब आई थॉट कि आप यहां से पिक कर चुके होगे, बट नो प्रॉब्लम, ये भी लिखना है. प्रेशर ग्रेडियंट इज इक्वल टू प्रेशर डिफरेंस डिवाइडेड बाय डिस्टेंस. ठीक है, प्रेशर ग्रेडियंट इज इक्वल टू प्रेशर डिफरेंस डिवाइडेड बाय डिस्टेंस. ऑलराइट, सो डियर डिड यू अंडरस्टैंड? सो अभी क्या हो गया हमें, एक तो आपको प्रेशर डिफरेंस का डायरेक्शन समझ में आ गया. इट इज ऑलवेज फ्रॉम हाई टू लो, सो यू विल जस्ट सी द नंबर्स. सेकंड, प्रेशर ग्रेडियंट. सो व्हाट इज द रेट एट विच द ग्रेडियंट इज चेंजिंग. सो फ्रॉम दैट यू विल अंडरस्टैंड व्हाट इज द स्ट्रेंथ ऑफ दैट फोर्स. सो स्ट्रेंथ ऑफ फोर्स एंड प्रेशर डिफरेंस इज गिविंग यू द डायरेक्शन ऑफ फोर्स. तो दोनों ही मिल गया. कम अगेन. व्हेन more strength of pressure gradient, what will happen? Wind will be faster. In what direction? In the direction, yes, that's it. Wind is always high to low ना. more या less से क्या फर्क पड़ता है? ऐसा तो है नहीं कि स्लोप चेंज करने से बॉल ऊपर जाने लगेगा. बॉल तो हमेशा ऊपर से नीचे ही आएगा, हाई टू लो, है ना? पक्का? और कोई डाउट है? माउंट एवरेस्ट से लुढ़को, बेड से लुढ़को, जाओगे तो नीचे ही. कभी ऐसा हुआ नीचे से लुढ़कते लुढ़कते ऊपर पहुंच गया? ठीक है, ऑलराइट, यस, विल कम टू आइसोबार, डोंट वरी, वी आर जस्ट कमिंग टू आइसोबार ओनली. और कुछ पूछो यार, मतलब पूछने का आपको आजादी है, बोलने का मुझे आजादी है, दोनों तरफ फ्रीडम. नो अदर क्वेश्चन? पक्का? चलो, सो शुड वी मूव ऑन? ओके, सो हाउ डू वी रिप्रेजेंट प्रेशर देन ऑन द सरफेस? जैसे आपने टेम्परेचर रिप्रेजेंट किया था ना अभी कुछ दिन पहले, एक दो क्लास पहले, टेम्परेचर आइसोथर्म. सो हाउ डू यू रिप्रेजेंट प्रेशर ऑन द सरफेस ऑफ अर्थ? आइसोबार्स. आइसोबार का मतलब क्या है? पढ़ के तो सब कुछ आए हो. इक्वल, आइसोबार मतलब इक्वल प्रेशर. हाँ, लाइन ऑफ इक्वल प्रेशर. सो लाइन ऑफ इक्वल प्रेशर मीन आइसोबार. ठीक है, पक्का? तो अगर वर्टिकली लाइन ऑफ इक्वल प्रेशर बनाए तो वो भी आइसोबार है. हाँ, हॉरिजॉन्टल. तो अगर माउंटेन पे बनाया तो वो भी है नियर हॉरिजॉन्टल. करते रहो यार, क्या फर्क पड़ता है? ठीक है, सो परफेक्टली फाइन. सो बेसिकली आइसोबार इज अ लाइन कनेक्टिंग प्लेसेस हैविंग सेम प्रेशर एट सेम हाइट, सो which are horizontally located और near horizontal. जो हमने horizontal और near horizontal हम बोलते हैं ना, horizontal किसके लिए? plains, and near horizontal for mountain surfaces. ठीक है, so what is an isobar? Isobar का definition, line connecting places having same pressure at horizontal level or near horizontal level. That's it, हो गया isobar. Is that okay? So this is what an isobar is. Clear? Right? So लिख लीजिए. Right? So what are we trying to answer? How do we represent pressure on the surface of Earth? How do we represent pressure on surface of Earth? How do we represent pressure on surface of Earth? The answer is by isobars. How do we represent pressure on surface of Earth? Answer, by isobars. Then what is an isobar? That's what you write. So what is an isobar? It is the line connecting places having same pressure on the surface of Earth horizontally or near horizontally. ठीक है? Line connecting places having same pressure on the surface of Earth horizontally or near horizontally. So let us say you are seeing from the space horizontally or near horizontally. That is the definition of isobar. ठीक है? Very good. So now all of you please see here. See on the board. Suppose you are looking from the satellite video. ठीक है? And on the surface of the Earth you find one isobar, and let us say this is 960 millibar का isobar on the plane. And let us say you have another isobar somewhere here which is 1040 millibar. ठीक है? Two isobars on the Earth's surface. So how will the wind move? From which to which? 140 to 90. So we can say that the air movement will be something like ऐसा. Do we agree? ठीक है ना? Air movement will be like this. So now my question is, how do winds move with respect to isobar? कैसा दिख रहा है? How do you draw the winds with respect to isobar? Parallel या perpendicular? ये wind जो है ये isobar से कैसा है? Perpendicular. Simple. ठीक है ना? So winds move perpendicular to isobar. लिखते जाना है, एक एक करके बढ़ते जाते हैं आगे. ठीक है? So winds move perpendicular to isobar. So first you wrote what is an isobar. Second you are writing what is the relation between wind and isobar. So winds move perpendicular to isobar. There is a condition, because science में हमेशा एक condition होता है. What is the condition here? If we are considering only the pressure gradient force, क्योंकि आप और कोई force तो ले नहीं रहे यहाँ पे. ठीक है? So that also we write. If we consider only the pressure gradient force. So winds move perpendicular to isobar if we take only the pressure gradient force. Is that okay? And what is the direction? It is always from high to low. तो ये सब बोलने का जरूरत नहीं है बार बार. ठीक है? जो समझ गया वही बार बार लिख करके कोई फायदा नहीं. All right? So should we go beyond? Now another diagram. ठीक है? क्योंकि डायग्राम से हम समझते जाएंगे इस पूरा कॉन्सेप्ट को. So let us say this time I give you a isobar somewhere here. यहाँ पे this is a 1040 millibar isobar, and this is a 1000 millibar isobar, and this side also I give you a 1000 millibar isobar. Okay, and I ask you to draw isobars every time 10 millibar pressure changes. कर सकते हैं? Draw isobars every time 10 millibar pressure changes, and this is the line A, and this is line B, and this is line C. So can you please draw other isobars? Where should they be? Assuming uniform change. ठीक है? तो assume क्या करना है? The change is uniform. So can you please draw me the other isobars at a interval of 10 millibar? बना सकते हैं? Please बनाइए. So every line, just show. So that line is basically trying to show by this much distance 10 millibar pressure has changed. है ना? Yes dear. कुछ doubt है चेहरा पे? We are not drawing isobar vertical. You did not. I think you missed my first line. मैंने क्या बोला था? कहाँ से देख रहे हो? देख कहाँ से रहे हो? Satellite video. ठीक है? अभी ठीक है? Do you need directions in this diagram? अभी चलेगा? ये भी बना लो. क्योंकि वो बाद में आप लोग को एज यू नो, जैसा इनको अभी डाउट आ गया 10 मिनट में, आपको हो सकता है 6 महीना बाद आए, ये सर ने वर्टिकल क्यों बना रखा है। तो डायरेक्शन बना दो ईस्ट वेस्ट नॉर्थ साउथ टाइप, ताकि पता रहे कि ये सीन फ्रॉम स्पेस है। Every time I draw the tropopause, I deliberately do it so that you understand that we are seeing vertically. And every time I draw east west north south, I deliberately want you to understand that I am trying to show you from north south east west। कौन सा डायग्राम में दिखेगा? जब आप ऊपर से देख रहे हैं, है ना। और ट्रोपोपॉज कब दिखेगा? जब आप वर्टिकल देख रहे हैं, ठीक है। सो ये हमेशा ध्यान रखना है ज्योग्राफी डायग्राम्स के अंदर। ऑलराइट, सो इज दिस क्लियर? सो हैव यू ड्रॉन? ओके, सो कितना आइसोबार बना? 4 बना दिया। मतलब यार इतना गड़बड़ करोगे तो कैसा चलेगा आप लोग का काम लाइफ में। 4 लाइंस कैसा बना दिया इसमें? 3 लाइंस, ठीक है, ऐसा बन गया। एवरीवन गॉट समथिंग लाइक दिस? नाउ इफ आई आस्क यू इन विच केस इज द आइस, सो can you tell me where the pressure gradient is high? Between what? AB or AC? Between what the pressure gradient is high? Is it equal? I'm asking between AB and AC. Between AB and AC, and I think आपको इसमें distance नहीं दिया है, so the distance between AB is 200 kilometers, and the distance between AB, sorry AC, नहीं A नहीं, BC is 100 kilometers, ठीक है। So where is the pressure gradient higher? Between what is the pressure gradient higher? BC. So we can say यहाँ पे pressure gradient high, and between BA pressure gradient low। नीचे लिखा है, दिख रहे? Everyone agrees? Pressure gradient high, pressure gradient low. So between BC the pressure gradient is high, and what is the where is the closeness of isobar more? Where is the closeness of isobars more, and where are the isobars more away from each other? BC they are close, and AB they are far. So what is the relation between isobar distance and pressure gradient? Higher the pressure gradient, ध्यान से देखो, हाइयर द प्रेशर ग्रेडियंट, हाइयर द प्रेशर ग्रेडियंट, हाउ मेनी ऑफ यू थिंक मोर? हाइयर द प्रेशर ग्रेडियंट, मोर इज द आइसोबार डिस्टेंस। हाइयर द प्रेशर ग्रेडियंट, मोर इज द आइसोबार डिस्टेंस। है कोई? हाइयर द प्रेशर ग्रेडियंट, लेस इज द आइसोबार डिस्टेंस। एवरीवन अग्रीज? And how many of you are still undecided? Higher the pressure gradient, we don't know what is happening. Data incomplete. Cannot attempt. Will leave in the exam hall. होते हैं ना, बहुत सारे ऑप्शन होते हैं एग्जाम में। तो everyone agrees? ठीक है। So what is the rule here? Higher the pressure gradient, closer the isobars. बोल सकते हैं? Everyone agrees? ये सब आप लोग रूल लिख रहे हो, यू नो, दीज आर द रूल्स एंड रिलेशंस, दीज आर योर प्रीलिम्स क्वेश्चंस, ठीक है। सो प्लीज डू राइट। व्हाट डू वी राइट? हाइयर द प्रेशर ग्रेडियंट, क्लोजर द आइसोबार्स, ठीक है। क्लोजर द आइसोबार और लेसर द डिस्टेंस बिटवीन आइसोबार, वो सेम है ना। क्लोजर द आइसोबार्स, हाइयर द प्रेशर ग्रेडियंट, क्लोजर द आइसोबार्स, क्लोजर द आइसोबार्स ऑफ सेम इंटरवल। ऐसा नहीं कि इंटरवल चेंज करके आप और क्लोज बना दो चीटिंग करने के लिए, 10 की जगह 5-5 का बना दिया, ठीक है। सो क्लोजर द आइसोबार्स एंड लेसर द प्रेशर ग्रेडियंट, फार्दर द आइसोबार्स, फार्दर द आइसोबार्स बोल सकते हैं। लेसर द प्रेशर ग्रेडियंट, फार्दर द आइसोबार, ठीक है। And what was the relation between wind speed and pressure gradient? You know. So now let me ask you the relation between you. आप बताइए. You. क्या नाम है इनका यार? Question. Should I ask you? हाँ. अभी बताओ, what is the relation between isobar and wind speed? The distance between isobar and wind speed क्या होना चाहिए? अब सब सोचो, because you know the answer. Pressure gradient of wind speed पता है, pressure gradient and isobar पता है, ठीक है? So what should be the relation between wind speed and isobar distance? बता सकते हैं ना? I need the answer. सब सोचो. First, all of you think, because probably that was your question. तो अभी सोचिए क्या आंसर होना चाहिए इसका? हाँ? Closer the isobars, closer the isobars, stronger the winds. बोल सकते हैं? And farther the isobar, weaker the winds. Do we agree? लिख डालो. जो जो चीज आप मुझे बताते हो सब अपना कॉपी में भी लिखना है. ये नहीं कि बस मेरा आके रिवीजन कराओ. इतने सारे बच्चे आओ, इतना सारा पैसा दो और आके मेरा रिवीजन कराते रहो क्लास में. ठीक है? So what do we write? Closer the isobars, stronger the winds, farther the isobars, weaker the winds. ठीक है? So did you get all the relation of isobar and wind? Okay. Can you also tell me what should be the wind direction and the isobar relation? Pressure gradient से तो आपने बता दिया, है ना? Wind direction. Wind direction is always high to low and direction with respect to isobar perpendicular to isobar. तो सबसे पहला winds are perpendicular to isobar if no other force. Second, closer the isobar, faster the wind, farther the isobar, slower the wind. और तो कोई relation चाहिए नहीं हमें, तो सारा relation हो गया. Is that okay? So do we understand these isobar relations also? Can we go beyond this? Pressure gradient, isobar, pressure difference, ये सब कुछ समझ में आया broadly? ये सब अलग अलग चीजें हैं, right? So you have to understand each of them separately and then you also have to understand the relation between them. So relations are clear? आगे बढ़े, ठीक है? Very good. So once you understand this isobar वाला relation and all, now let us come to the next thing. कोई डाउट है तो पूछिए. नो डाउट? No doubt? Very good. So now, so before we go beyond this, we also have to understand that is the pressure gradient. Now please all of you, ठीक है, इतना समझ में आ गया. अगर बिकॉज डाउट था तो यू आस्क मी डायरेक्टली, आपस में डाउट्स मत पूछो, दैट माइट नॉट हेल्प. ठीक है, क्योंकि हो सकता है साथ वाला भी आपके ही लेवल पे हो, यू नो, एंड दैट इज द बेस्ट केस सिनेरियो, राइट? तो अगर वो आपसे थोड़ा भी ऊपर नीचे हुआ तो आपका भी उसी डायरेक्शन में प्रेशर ग्रेडियंट में मूवमेंट होना शुरू हो जाएगा. ठीक? तो कमिंग बैक, सो if this much is clear and I'm assuming no doubts, and do I see any online doubt? Ma'am, anything online? Nothing? Everything clear? सबको clear है? Online people, आप लोग भी खुश है, happy है ना? घर पे बैठ के work from home चल रहा है आप लोग का. So okay, so now let us move to the next thing, okay, which is understanding, is there any other force which acts on the wind? ठीक है, सो अभी हमने क्या बोला? वी हैव सीन द विंड विद रिस्पेक्ट टू विच फोर्स? ओनली प्रेशर ग्रेडियंट फोर्स. बट आर देयर अदर फोर्सेज ऑन द विंड्स? राइट, दिस इज व्हाट वी नीड टू अंडरस्टैंड. ठीक है, सो शुड वी ट्राई टू अंडरस्टैंड फोर्सेज ऑन विंड्स, राइट? दैट इज योर नेक्स्ट हेडिंग, फोर्सेज ऑन विंड्स. Alright. So when we talk of forces on winds, let me ask you this way. Till now you have understood that winds are moving because of one driving force which is trying to push it in a, you know, or push it, rather than I should say direction, I should say it is trying to push it. And Do the winds always move in one given direction, or do they keep moving and they keep changing directions? What do we see? Do they change directions? So if they are changing direction, there could be forces, right? Maybe it is the pressure gradient force, or maybe there are other forces. So basically, if you see the wind, there are two things which are happening with the wind. One, it is moving, and second, it is also taking directions. Can we say this? Any wind is one, moving, and second, it is also taking directions and changing directions. है ना? Have you seen something like this in your real life, which is moving and changing directions also? जैसे? Very good. Cycle or car. है ना? So let us take the example of car, because I find it the most relevant for most of you to understand. So if I take a car which is moving, right, and changing directions both, करता है कार, दोनों करता है ना? Car moves and car changes direction. So why does it move? Why does the car move? Huh? Force applied by? Force applied by? Very good. So there is a engine force. इंजन फोर्स है ना. कई लोग बोलते हैं सर फ्रिक्शन का वजह से कार मूव करता है. एक काम करो, इंजन निकाल के रख दो और फ्रिक्शन पे दौड़ाते रहो. So what makes the car move? Right. So the engine force is like the pressure gradient, which is moving the car or the wind. Is this clear? So engine is like pressure gradient. And what gives direction to the car? हाँ? Direction कहाँ से मिलता है? There is something like a steering in the car, and by changing the steering, you change the direction of the car. ऐसा ही होता है ना? Now help me understand. If the engine is not on and if you keep changing the steering, will the car go anywhere? बचपन में बहुत ट्राई मारा है आप लोगों ने, सभी ने मारा है ना? गाड़ी का चाबी लेकर के 1 घंटा गाड़ी चला है, पापा खुश, आप भी खुश, गाड़ी कहीं गया भी नहीं और आप लोग चला भी आए. ठीक है? So what does that imply? Steering force in itself does not move the car anywhere. So when does the steering force come into play? Only when the engine is on and the car is in motion. ठीक है? So steering force by itself does not change the direction alone if there is no driving force. ठीक है? So there are two types of forces in the car, and same ways in the wind also you will have two types of forces. तो एक engine force हो गया और दूसरा steering force. Now same thing applies to winds also. Winds also have a moving force or what you call as a driving force. ठीक है? ड्राइविंग, ये जो इंजन फोर्स है इसको हम ड्राइविंग फोर्स बोल सकते हैं. ड्राइविंग फोर्स, एंड देन winds also have steering force. ठीक है? So what is the driving force and what is the steering force? Which is the driving force in the wind? If it is moving horizontally, the only driving force is pressure gradient. ठीक है? So जब तक आप wind का बात कर रहे हो तब तक which is the only force? Wind मतलब horizontal or near horizontal, then only pressure gradient. ठीक है? So for winds it is only PGF. ठीक है? और ये सब लिखना भी है कॉपी में. मतलब मुझे तब थोड़ा सा शौक लगता है जब आप लोग आराम से बैठ के ना स्वस्थ सर हिलाते हैं. हाँ जी सर, आप बिल्कुल सही बोल रहे हो. राइट है सर, आपको सब आता है. कॉपी में लिखना भी है. Okay, right? So steering, so wind only pressure gradient, whereas when you talk of draft, in case of draft there is an additional force which acts, gravity and buoyancy. BUOYANCY, gravity and buoyancy. Gravity will cause heavier air to come down and buoyancy will cause lighter air to rise up. So basically buoyancy and gravity are nothing but they are just the same phenomena. ठीक है? उसी का दो नाम है. एक न्यूटन ने फाइंड किया, दूसरा आर्किमिडीज ने, बट फिनोमेना सेम है. लाइटर विल गो अप and denser will go down. So if you are saying denser will go down, that automatically means that lighter will go up, क्योंकि denser नीचे जा रहा है तो किसी के against ही जा रहा होगा ना. Is that okay? ठीक है, right? So now which are the steering forces? So driving force तो हमें समझ में आ गया. And because we do not focus too much on draft का हमें ज्यादा बात करना नहीं है, so we leave this part. ठीक है, because we are not talking too much of updraft and downdraft, we are mostly talking of winds, right? So this other part we generally do not consider. Now if I ask you, does the gravity also play a role in wind movement? Yes or no? Right? You can get the answer from the fact, if you just compare this with, does the car move because of gravity? What does the gravity do to the car? Gravity holds the car at the same level. Okay, and on all cars, irrespective of whether engine is there or not, gravity is acting. तो इसीलिए anything which is too universal, we do not consider it. ठीक है, क्योंकि वो तो सभी पे है. Therefore, for wind motion, we do not consider. Why? Because it is universal. वो सब पे ही हो रहा है. ठीक है, and gravity is not making the wind go anywhere. ठीक है, what is making the difference? What is making the difference here? The pressure gradient. Gravity is not making the difference. Is that okay? तो इसीलिए हम सिर्फ pressure gradient का ही बात करेंगे. We will not talk of gravity. Is that okay? मैंने आपको पहले बोला था ना, gravity is like mother earth's love. ठीक है, तो वो माँ का प्यार है, तो उसको हम सब बिल्कुल ऐसा ही for granted ले लेते हैं. यहाँ पे भी जैसे आप सबको ही मम्मी का लव मिलता है, बट इफ आई आस्क यू, आप लोगों को कोई प्यार करता है, आप बोलोगे नहीं सर. है ना, मम्मी का प्यार तो कंसिडर ही नहीं होता यार धरती पे. ठीक है, कहीं और ही ढूंढ रहे होते हो. ओके, राइट. सो वैसे ही ग्रेविटी भी है बेचारा, उसकी कोई इज्जत नहीं है. ठीक है. सो एनीवेज, कमिंग बैक. सो ड्राइविंग फोर्स अंडरस्टूड, राइट. देन व्हाट इज स्टीयरिंग फोर्स? Steering force. Now when we talk of steering force, there are different steering forces which act. Which are they? The most important here is the Coriolis force. ठीक है. So one, Coriolis force. दूसरा, frictional force. These are the answers that I expect you to have from your NCRTs और GC Leong, अगर पढ़ा है तो. ठीक है. समझ में आया नहीं आया, दैट्स अ डिफरेंट थिंग, बट यू शुड बी नोइंग. ठीक है, एनसीईआरटी एटलीस्ट इतना कर देता है कि इंफॉर्मेशन दे देता है. समझो ना समझो आपके ऊपर है, राइट. सो कोरियोलिस फोर्स, फ्रिक्शनल फोर्स, देन सेंट्रीपिटल फोर्स एंड सेंट्रीफ्यूगल फोर्स. एंड सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्सेज आर सच दैट ऑन एनी रोटेटिंग ऑब्जेक्ट one acts inward, the other acts outward. So centrifugal acts outward and centripetal acts inward, and hence they cancel each other. So because they cancel each other, hence we do not consider them. इसको भी छोड़ देंगे. But they are forces which act. ठीक है? But because they cancel, so we do not consider. So if there is a prelims question, which all forces are the steering forces? So centripetal and centrifugal are also, but they are just cancelling each other in case of rotational motion. ठीक है? इतना ध्यान रखना है. Is this okay? ठीक है? So which two forces are the varying forces here, which do not cancel? Coriolis and frictional force. So now if I ask you, do you understand pressure gradient force? So that we can move on. Pressure gradient force समझ में आ गया? पक्का? Everyone is clear? So now should we come to understanding of Coriolis force and frictional force? What role do they play? ये भी देख लेते हैं. Should we? Very good. So what is Coriolis force? The next subheading. Right. So what is Coriolis force? You have to understand. Now, before I show you Coriolis force, I'll show you a video. ठीक है, पहले थोड़ा वीडियो देखो, आराम से एंजॉय करो. Coriolis force तो समझ ही जाओगे. ठीक है. So now everyone please focus here. I'll play the video for around 30 seconds or so. Then I'll put my questions and then again put the video. तो थोड़ा ध्यान से देखना है कि हो क्या रहा है. ठीक है. All of you could see? तीन बार चल चुका है. मतलब मैं अगर कुछ बोलूं ना, चलने दो यार. क्या जा रहा है? ठीक है. बंद कर दो सर. क्यों? अच्छा, चक्कर आ गया. मत देखो यार. कोई फोर्स थोड़ी किया है. नहीं, हाँ कि आंखों में ऐसा लगा करके घोड़े के जैसा उधर ही किया हुआ है, वही देखते रहना. मत देखो. ठीक है, perfectly fine. So now my questions. Should I ask you? Right. So I want you to write these questions and then probably watch the video again and give me the answers. ठीक है? Right. So the first question is, as most of you can see that the merry-go-round is going around. दिख रहा है ना? वो fix तो है नहीं. So what is the direction of merry-go-round motion? Clockwise or anti-clockwise? Answer चाहिए copy में. आपका मुंह से नहीं चाहिए. I need all these answers in your copy. Right? What is the direction of rotation of merry-go-round? What is the direction of rotation of merry-go-round? ठीक है. Clockwise, anti-clockwise, cannot determine, जो भी बोलना है बोलो. ओके. और इस आंसर के लिए भी अगर साथ वाले का कॉपी देखना पड़े कि क्लॉकवाइज है या एंटी क्लॉकवाइज है. सो मैरी क्या बोलते हैं ऐसे, हिंदी का वर्ड क्या है इसके लिए? वो गोल वाला झूला. अभी ठीक है, हिंदी में लिख लो. इन व्हाट डायरेक्शन इज द गोल वाला झूला घूमिंग? whichever way you understand. ठीक है. So in what direction is the merry-go-round rotating? What is the answer? Everyone agrees, right? Perfectly fine. Second, is the ball with which the kids playing deviating or moving straight? I need one word answer. लिखना है. That the ball is deviating, right? Deviating or going straight. That is what you have to write. The ball is deviating or going straight. So whatever you write, the ball is deviating, you write as per me. And if you are writing the ball is going straight, you write as per me. मुझे आपका आंसर चाहिए, साथ वाले का नहीं. ठीक है. तो इसीलिए आराम से ध्यान से देखो और फिर आंसर लिखना है. इज द बॉल डेविएटिंग और मूविंग स्ट्रेट? एज पर मी. सो व्हाट डू यू प्राइमा फेसी फील? सबसे पहला लगता क्या है? एंड गिव मी दैट आंसर फर्स्ट. दैट द बॉल इज डेविएटिंग एज पर मी. ठीक है. तो ये लिख लेना है. अभी के लिए ये लिखना है. ठीक है. दैट द बॉल इज डेविएटिंग एज पर मी. नाउ इफ द बॉल इज डेविएटिंग, इन व्हाट डायरेक्शन ऑफ द पर्सन थ्रोइंग? In what direction to the person throwing is the ball deviating? what direction of the person throwing is the ball deviating? The options are left and right. वो भी लिखना है. The ball seems to deviate to the left with respect to the person throwing. ये पूरा लिखना है. The ball seems to deviate to the left with respect to the person throwing. लिख लिया? Very good. Okay. Now please see, all of you, carefully. If the ball is deviating, right, which you say, and as you can see that the person is throwing the ball and the ball is not going to the person sitting opposite, but it is going to the person sitting on the left of the person throwing the ball. ठीक है, यहां तक तो हमें दिख रहा है. बट अब थोड़ा फिर से देखते हैं कि इज द बॉल रियली डेविएटिंग. ठीक है. नाउ प्लीज ऑब्जर्व, वेयर इज द बॉल राइट नाउ? विद होम? येलो. ठीक है. सो प्लीज सी व्हाट हैपेंस टू द बॉल, और वेयर डज ही रिलीज द बॉल. ठीक है. वेयर इज दिस पर्सन गोइंग टू रिलीज द बॉल? वो देखना है. राइट. So this person goes on to release the ball. Somewhere here. And this is the center of the merry-go-round. ठीक है. तो यहां से बॉल रिलीज किया ना इसने, पक्का. And then finally you have to see where is the ball caught. क्या देखना है? Where is the ball caught on the merry-go-round. ठीक है. मैं देख रहा हूं चेहरे पे, कईयों कहां कैसा हो गया, ये क्या हो गया, है ना. Right. So now answer. ये क्या है? How is the ball going? अच्छा, अभी विश्वास नहीं हुआ है सर, आपने जरूर कुछ तो घपला किया वीडियो में. अब आराम से देखते रहो. ठीक है. That question will again come because the video is in loop. ठीक है ना. पहले भी आपने 4 बार देखा है. आ गया? हाँ. Yes. So tell me, is the ball deviating? In reality, is the ball deviating? Yes or no? In reality, is the ball deviating? No. And what did you perceive? That the ball is deviating? है ना. तो आपके हिसाब से तो बॉल डेविएट हुआ, बट इन रियलिटी द बॉल वेंट स्ट्रेट. बट हाउ डू यू अंडरस्टैंड दैट द बॉल वेंट स्ट्रेट? उसको देखने के लिए आपको कहां जाना पड़ा? वेयर डिड यू हैव टू गो टू सी दैट द बॉल इज नॉट डेविएटिंग? ऑन द मेरी गो राउंड और अवे फ्रॉम द मेरी गो राउंड? ऑन द रोटेटिंग मेरी गो राउंड और अ स्टेशनरी सर्फेस? सो व्हेन यू आर ऑन स्टेशनरी सर्फेस विद रिस्पेक्ट टू द मेरी गो राउंड रोटेटिंग, where you can see the rotation of the merry-go-round, then you could figure out that the ball is actually going straight. And if the ball is going straight, is there a force acting on it to deviate it? If the ball is going straight, if Newton ka law, what does Newton say? If anything is moving straight, it will continue to move straight till external force applies. So if it is moving straight, is there an external force? Is there any force acting on this ball to deviate it? No sir, which means that there is no force acting and hence the ball is in reality not deviating. Do we agree? ठीक है. ऐसा कभी रियल लाइफ में भी होता है, right? There are many examples of this kind, but there might be of different setup, not exactly same. For example, I'll give you another example which might help you understand. Let us say you are moving in a train and you are sitting in the train and you have a ball in your hand and you throw the ball up As you throw the ball up, the ball comes back to you only. ऐसा तो नहीं कि आपने बॉल ऊपर फेंका और पीछे वाले के मुंह पे जाके लग गया, है ना? बॉल तो आप ही के हाथ में आके गिरता है. Do you agree? So to you, the motion of the ball is a straight line motion, है ना? While you are sitting in the train, to you the ball motion is a straight line motion. ठीक है? But by the time the ball goes up and comes back, the train has moved here. है ना? So what is the real motion of the ball? इतना ऊपर नहीं गया. So ball actually did a projectile, but you saw straight line. Why? Because you yourself are in a moving train. ठीक है? And the ball's this motion speed is same as your this motion speed. आप दोनों का स्पीड कांस्टेंट है, थैंक्स टू द ट्रेन. इसीलिए आपको ये मोशन दिखेगा ही नहीं. ठीक है? सो विच मोशन डू यू सी? ओनली द स्ट्रेट मोशन. डू यू गेट इट? सो नाउ सेम थिंग इज हैपनिंग हियर ऑल्सो, राइट? सो नाउ टेल मी, if you try to talk to these, now assume one thing, assume that these kids were born on the merry-go-round. वो पैदा ही उधर हुआ था. assume करना है लाइफ में, assume कुछ भी कर सकते हैं. they were born on the merry-go-round and since they are born the merry-go-round is going round and round. वो रुका भी नहीं merry-go-round कभी. ठीक है? and they have been playing with the ball since their childhood. वो जब से पैदा हुआ है बॉल से खेल रहा है और बॉल हर बार. So can you make these kids understand that the ball is actually not deviating? आप उनको बता सकते हैं कि ये बॉल डेविएट नहीं हो रहा है. अगर आप जाके बोलोगे kids you don't know these balls are not deviating, they are going straight, what will the kids say? कितना इंटेलिजेंट हो आप लोग, है ना? राइट? डू यू गेट इट? You can't make those kids understand that the ball is not deviating because they are born and since they are born the ball is deviating. ठीक है? Is that okay? Now who are those kids? ठीक है? And what is that merry-go-round? Earth is that merry-go-round. और वो बच्चे आप ही हैं. ठीक है? तो आपको कोई भी आके समझाएगा that the ball is going straight, आप क्या बोलोगे? इसीलिए मैंने अभी तक बोला नहीं. आपके ऊपर ही छोड़ दिया, खुद फिगर आउट करो. ठीक है? All right. So is this clear? Right? So now the idea that you have to understand here is the way you have ball moving on a merry-go-round on the earth, what is moving across long distances? क्या ऐसा चीज है which is moving across long distance? Winds, missiles, aeroplanes, they are moving long distance. Ocean currents, right? All these objects are moving long distance. They are like the ball, okay, which are moving long distance over this merry-go-round. And as they go that long distance, they will seem to us, they will seem to be bending. है कि नहीं? To us, they will seem that they are all bending. Is that understood? Right? And because to us they are bending, and Newton told us that if anything is bending, there must be a force. तो एक कोरियोलिस नाम के व्यक्ति थे. He stood up and he said, bend हो रहा है, मेरा ही फोर्स है. सबने बोला हाँ, वैसे भी हम ये मानने वाले तो है नहीं. ठीक है? तो आप ही का नाम रख देते हैं. Right? So because of Coriolis figuring this out, we gave his name to the force and call it as Coriolis force. Why? Because if we do not give that force a name, then all our Newton laws will be failed on the motion of winds and all. वो अप्लाई नहीं होंगे क्योंकि हमारा अर्थ के हिसाब से if anything is bending, there must be a force. ठीक है? So Coriolis force is it a real force? Is in reality anything bending? No. But just to ensure that our laws go perfectly fine, we have created our own force for the bending winds. ठीक है? Now the next question. What direction is the earth rotating? The merry-go-round. West to east. ठीक है? Like this, ऐसा. ठीक है? So if I ask you that in what direction is the earth rotating seen from the north pole? What direction is this? Huh? Anti-clockwise. So, because the north hemisphere, from the north hemisphere, the earth is rotating anti-clockwise, the deflection should be to the, आपका copy में देखो, when the merry-go-round was going clockwise, the deflection was, so right now the merry-go-round is going anti-clockwise seen from northern hemisphere, hence the objects in the northern hemisphere will deflect to the right, and the same earth, ठीक है, same earth seen from the southern hemisphere, same earth, डायरेक्शन चेंज नहीं किया मैंने, as you can see कोई चीटिंग वीटिंग नहीं हो रहा है यहाँ पे, ठीक है, so same earth seen from the southern hemisphere clockwise, hence the deflection left. So Coriolis force का deflection दोनों हेमिस्फीयर में, do we understand this? ठीक है, so that's it, this is Coriolis force. ठीक है, so it's a force which is actually not there. ठीक है, बट लगता हर जगह है. हाँ, ये एंटी गॉड के जैसा है. गॉड दिखता कहीं भी नहीं है हर जगह. ये है कहीं भी नहीं, दिखता हर जगह है. ठीक है, तो कुछ अलग टाइप का फिनोमेना है. बट डू वी अंडरस्टैंड दिस? राइट नाउ you can read lot many literature about Coriolis force, but I don't find any of them pretty convincing because वो सारे साइंस में घुस जाते हैं. एंड साइंस में घुसने से प्रॉब्लम ये होता है कि बहुत सारे लोगों को एग्जाम में लिखना मुश्किल हो जाता है. ठीक है, so we won't get into the science of it and it is not even needed. UPSC doesn't ask you those kind of questions, at least in geography. ठीक है, so हम उतना ही लिखेंगे जितना जरूरी है, और है या नहीं है वो आप खुद डिसाइड करो. ठीक है, कि कोरियोलिस फोर्स है या नहीं है. बट व्हाट इज द आंसर रियली? है या नहीं है? नहीं है ना, बट दिख जाता है ना. जैसा आप छोटे थे आप बोलते थे भूत भूत, दूसरा क्या बोलता है? नहीं है. तो कोरियोलिस फोर्स भी भूत के जैसा है नहीं, बट हर जगह दिखता रहता है. ठीक है, ओके, वेरी गुड. सो लेट अस राइट दिस डाउन. So the heading we have written Coriolis force, right? Under that write down, because, and by the way, if I ask you why do you see this Coriolis force, what is the real cause of this Coriolis force? Rotation of the earth, right? That is the relative motion, because while the wind is moving you are also moving. So because you and wind both are moving, there is a relative motion between you which causes you to think that there is a bending. Is that okay? So rotation of the earth is the real culprit here, or the cause here, which makes us feel that there is Coriolis force. Is that okay? ठीक है. So write down that due to the rotation of the earth, due to the rotation of the earth, due to the rotation of the earth, objects moving in the northern hemisphere, objects moving in the northern hemisphere seem to bend to the right, seem to bend to the right when they move over long distance, when they move over long distance, such as winds, currents, aeroplanes, missiles, winds, currents, aeroplanes, missiles, etc. And in the southern hemisphere, they seem to deflect to the left. Also, but this is mainly due to rotation of the earth, This is mainly due to rotation of the earth, because when we see the same motions, when we see the same motion from outside the rotating frame of earth, see the same motion from outside the rotating frame of earth, when you go outside the rotating earth and you see the same motion, right? When we see the same motion from outside the rotating frame of earth, we find that the objects are moving. We find that the objects are moving in reality in a straight line. In reality in a straight line. Hence, we find that the objects in reality are moving in a straight line. Okay, full stop. Hence, Coriolis force is a pseudo force. Coriolis force is a pseudo, P-S-E-U-D-O. Right? Pseudo force or apparent force. Apparent. Pseudo force or apparent force. Apparent matlab something which seems to be there but in reality it is not there. Okay? So pseudo force or apparent force. Is this clear? And hence it is not a real force. Hence it is not a real force. Also, but for all practical purposes on earth, we consider it to be existing. We consider it to be existing. Is that okay? Clear? Very good. Now, other characteristics of Coriolis force. Other characteristics of Coriolis force. The Coriolis force over the equator. Coriolis force over equator is zero. Is zero because the deflection is zero. Coriolis force over the equator is zero because the deflection is zero over equator. And it is maximum near the pole. It is maximum near the pole. Okay, full stop. Second, it does not affect the speed of the wind. It does not affect the speed of the wind. For example, the speed at which you turn the steering of a car does not affect the speed of the car. है ना? Steering जो force है, वो car का speed तो change करती नहीं है. So that's what we are saying. It does not affect the speed of the wind. Why? Because it's a steering force. ठीक है? It does not affect the speed of the wind, but it is affected by the speed of the wind. It is affected by speed of the wind. What does this mean? Suppose you have two cars, one going fast, the other going slow, and two people sitting in them are turning the steering at the same speed. In which case the car will tend to turn fast. The faster car will tend to turn fast and the slower car will tend to turn slow. है ना? So the steering force can be affected by the speed of the wind, because the steering turning can be affected by the speed of the car. Faster cars will turn faster and slower cars will turn slower. So same thing we are trying to say in this, that faster the speed of the wind, faster will be the effect of steering force. वही आपने लिखा है. That's what you have written, right? Which means faster the winds, stronger will seem to be the, which means faster the wind, stronger will seem to be the Coriolis force. Faster the wind, stronger will seem to be the Coriolis force. Is that okay? Underline this. Faster the wind, stronger will seem to be the Coriolis force. Okay. Now tell me whether this statement is right or wrong. The one that I'm going to say. Stronger the Coriolis force, faster will be the wind. No. ये इसका उल्टा है. But that is not right. Is right? वो अभी आपने लिखा था इधर पहले. But faster the wind, stronger will be the Coriolis force. Closer to equator, Coriolis force will be great. Where will it be greater? Near the pole. Okay, so near the pole it is stronger, near the equator it is minimum, zero, wind speed, relation, all this is clear. So these are the broader things which we need to understand with respect to Coriolis force and its effects. So is this okay? I think that's it. This is all that we need to do with respect to Coriolis force. And does it affect the direction of the wind? Does it affect the direction of the wind? Does it affect the speed of the wind? Speed, no. Direction, yes. All right, very good. And yeah, बोलो. Equator पे affect क्यों नहीं कर रहा है और उसके ऊपर क्यों कर रहा है? Is that your question? ठीक है. Wait. I'll just give you the answer. Don't worry. Let me just check one more thing. Now, just imagine. अब थोड़ा imagine करना है आप सबको. All of you, please see here. Just imagine that this is the merry-go-round. वो जो वीडियो आप देख रहे थे वो यही है. So where are the kids sitting? On the pole or at the equator? वो बच्चे चारों कहाँ बैठे हुए हैं? If this is the merry-go-round, where are the kids sitting? On the equator. Pole तो ये है. Now just imagine that the kids are throwing the ball. तो जो ball फेंक रहे थे, was the ball going to the side or was it going straight? In that video, straight, which means was there Coriolis effect? If you are throwing and it is going straight, is there a Coriolis effect? So on the equator, is there a Coriolis effect? No. When the other boy was catching the ball, was he catching in the side or was it catching in the front? वीडियो देखो, कोई बात नहीं. इसीलिए मैंने कहा था ध्यान से वीडियो देखो. आप लोगों ने वीडियो ध्यान से नहीं देखा. See the kids. Are they catching the ball straight or are they catching the ball turning to the side like this? ध्यान से देखो आराम से. I am in no hurry. Are they catching the ball straight or are they really bending to catch the ball? So if they are catching the ball straight, that means the ball while coming to them, is it bending or not bending? Not bending, which means on the equator, while going away, it is not bending. While coming, again it is not bending. So what is the force, turning force on the equator? Zero. And then where is the ball bending the maximum? By the time the ball reaches the middle of the merry-go-round, it has completely bent. And what is the middle of the merry-go-round? Pole. ठीक है? So at the pole it will seem to be deflected the maximum and at the equator it will seem to be deflected the minimum. Do we get the answer? ठीक है? So at the equator, hence at the equator the bending is minimum and at the pole the bending is maximum. वो आप लिख चुके हो, nothing to write. It's already there in your copy. ठीक है? Clear है? Any other doubt? Yes or no? No doubt. Very good. So you have written everything with respect to Coriolis force. Now let us come to the next force. So Coriolis force का काम is over. Okay, and now let us come to frictional force. Should we? है time, जल्दी से complete कर लेते हैं. हाँ जी, बोलिए, listening. How the wind affects the. Have we written something? The wind affecting the Coriolis force. लिखा है. Wind के पास क्या क्या चीज है? एक speed है. Does the speed affect the Coriolis force? लिखा है ना? Does the speed affect Coriolis force? Yes. Stronger the speed, stronger the Coriolis force. So that is the effect of wind on the Coriolis force. ठीक है? So that is the effect of wind on the Coriolis force. बोल सकते हैं? ठीक है? Okay. Now let us come to the second part. कौन सा है? Friction. Now see, Coriolis force में I could make you write lot many things, but that won't make much sense. Right? Reason being, वो सब आपका NCERT में anyways है, तो आप वहाँ से रट लो. Right? The logic that I wanted you to understand here was very simple. That there is nothing like Coriolis force in reality, but still Because it is an outcome of the rotation of the earth, and hence we feel that there is a Coriolis force, and because we feel there is a Coriolis force, hence we have just created the whole science of Coriolis force, right? So that our Newtonian laws are not failed. ठीक है, तो वो उस पर्पस से हमने सारा कुछ किया हुआ है, क्योंकि एक तो हमें दिखता है कि ऐसा कुछ बेंड हो रहा है, एंड देयरफॉर वी हैव केप्ट अ नेम टू इट एंड वी हैव created equations etc. So that, but basically what are we trying by doing all that Coriolis calculation, what are we trying to factor? रियलिटी में हम क्या चीज फैक्टर कर रहे हैं? अर्थ रोटेशन. द रिलेटिव इफेक्ट ऑफ अर्थ रोटेशन इज व्हाट वी आर ट्राइंग टू फैक्टर, क्योंकि हमारे हिसाब से अर्थ तो रोटेट हो नहीं रहा है. ठीक है, तो हमारे किसी भी कैलकुलेशन में अर्थ का रोटेशन तो होता नहीं है. आ रहा है समझ में? बट व्हेन यू टॉक ऑफ लॉन्ग डिस्टेंस मूवमेंट, अर्थ रोटेशन कम्स इनटू प्ले. सो हाउ डू वी फैक्टर इट? यूजिंग कोरियोलिस फोर्स फॉर लॉन्ग डिस्टेंस मूव. तो वही हमने वहां पे इक्वेशन कोरियोलिस फोर्स के नाम से यूज किया हुआ है. इज इट ओके? बट बेसिकली वी आर डूइंग नथिंग बट फैक्टरिंग द इफेक्ट ऑफ अर्थ रोटेशन ऑन अदर मूविंग ऑब्जेक्ट्स. ठीक है, हाँ जी. Centripetal force is a pseudo force. Centripetal is the force. Basically any object, suppose centripetal force act कैसे करता है? Suppose you have a thread. So we say that an object which is trying to go this way is pulled by the thread into this direction. That's your centripetal force. ठीक है, and any object which is, so basically what is happening is at every stage the angle is changing. That's why we say that the velocity is changing. और उसकी वजह से हम बोलते हैं वहाँ एक एक्सेलरेशन है. सो वहाँ पे फोर्स है, उसको फैक्टर कौन सा करता है? सेंट्रीफ्यूगल फोर्स विच इज आउटवर्ड. सो द ऑब्जेक्ट ट्राइज टू गो आउटवर्ड एंड द थ्रेड ट्राइज टू कीप इट इनवर्ड. ऑब्जेक्ट इज गोइंग आउटवर्ड, थ्रेड इज कीपिंग इनवर्ड, सो द ऑब्जेक्ट गोज नोवेयर. कैंसिल हो जाता है एक दूसरे से. और ऑब्जेक्ट नीदर गोज अवे फ्रॉम द सेंटर नॉर कम्स क्लोज टू द सेंटर, कीप्स रोटेटिंग, बिकॉज सर्कल इज नथिंग बट इक्विडिस्टेंट. सर्कल का डेफिनेशन यही होता है ना, इक्विडिस्टेंट पॉइंट फ्रॉम द सेंटर, राइट? तो उधर मूव कर रहा है वो आराम से. ठीक है, सो ऑब्वियसली बहुत सारे जगह पे हम ये सब रूल्स लगाते हैं. ओके, सो बट लेट्स नॉट गेट इनटू दैट राइट नाउ. अभी हमें सिंपल तरीके से क्या समझ में आया? सिंपल भाषा, व्हाट विल वी राइट? वो जितना लॉज आपको चाहिए एग्जाम के लिए उतना आपका कॉपी में है, और उसका इफेक्ट क्या है वो भी आपका कॉपी में है. सो कैन वी गो बियॉन्ड? आगे बढ़ जाएं, राइट? सो विच वन इज द नेक्स्ट वन? फ्रिक्शन फोर्स. सो व्हाट डज फ्रिक्शन डू? By the way, before I start with friction, what is the relation between speed and Coriolis force? Higher the speed, higher the Coriolis force. इतना सबको याद रहेगा? Very good. What does friction do to speed? Friction reduces the speed or increases the speed? Reduces the speed. So higher the frictional force, lesser the speed. Higher the speed, higher the Coriolis force. So lesser the speed, lesser the Coriolis force. Hence higher the frictional force, lesser the Coriolis force. Hence what is the relation? That's it. So what is the relation between Coriolis force and frictional force? Inverse. Why? Because Coriolis force increases with speed and frictional force reduces speed. ठीक है, so higher the frictional force, अभी लिखना नहीं है, I'll dictate. Higher the frictional force, lesser the speed and hence lesser the Coriolis force. Now what was the ultimate outcome of Coriolis force? Lesser the force तो समझ में आ गया, लेकिन हमको force से तो मतलब नहीं है. We are interested in the effect of the force. So what is the effect of Coriolis force? In the northern hemisphere, bends to the right. Does it increase the speed? तो speed से तो Coriolis force का कोई relation नहीं है. So in the northern hemisphere, Coriolis force bends to the, and in the southern hemisphere bends to the left. इतना clear है? So higher the Coriolis force, higher will be the bending, and higher the frictional force, lesser will be the bending. Which means if the Coriolis force is trying to bend to the right, what is the final effect of frictional force? Coriolis force is trying to bend to the right, then we can say that the frictional force is trying to bend to the left. बोल सकते हैं ना? Right? So this is the apparent effect of frictional force. Friction actually ऐसा कुछ करता नहीं है, वो सिर्फ स्लो डाउन करता है. बट व्हाट इज द अपरेंट इफेक्ट? अपरेंट मतलब व्हाट वी सी. व्हाट इज द अपरेंट इफेक्ट? इट सीम्स दैट frictional force is trying to oppose the rightward bending, and hence we say that frictional force is trying to apply a leftward force in the northern hemisphere and opposite in the southern hemisphere. आ रहा है समझ में? So frictional force का steering effect क्या है? Steering effect. It opposes the Coriolis force, and hence in the northern hemisphere frictional force appears to bend to the left or right? Left. And in the southern hemisphere to the, that's it. ठीक है, ये उसका steering effect है. Right? Is that okay? So should we write this? So let us now write one by one. First thing that you have already written above, that higher the Coriolis force, higher the speed. I am not dictating. Let us go beyond that. Frictional force tends to slow down. Frictional force tends to slow down the speed. Full stop. Slower the speed, lesser the Coriolis force. Slower the speed means lesser the Coriolis force. Hence, simply said, higher the frictional force, lesser the Coriolis force. Underline this. Higher the frictional force, lesser the Coriolis force. इतना underline करो. Next paragraph. The steering effect of Coriolis force was bending right in northern hemisphere. Steering effect of Coriolis force was bending right in northern hemisphere. Bending right in northern hemisphere and left in southern hemisphere. Right in northern hemisphere and left in southern hemisphere. And because frictional force opposes the steering force, as seen above, frictional force opposes the steering force as seen above. Hence, we can conclude that the steering effect of frictional force is bending to left in northern hemisphere. Bending to left in northern hemisphere. Bending to left in northern hemisphere and right in southern hemisphere. Right in southern hemisphere. Steering effect of frictional force is bending to left in northern hemisphere and right in southern hemisphere, within bracket, opposite to the bending of Coriolis force. Within bracket, opposite to the bending of Coriolis force. ठीक है? Is this okay? So this is the steering effect. If the Coriolis force seems to be bending to the right, the frictional force will seem to be bending to the left. That's it. ये इसका steering effect है और ये apparent steering effect है. Because in reality, frictional force does not bend. It just opposes the Coriolis effect by slowing down the wind. वो सिर्फ wind को slow कर रहा है. But slowing effect is that as if some force is acting opposite to Coriolis force. Is that okay? Clear है? पक्का? So do we understand friction force? Right? And higher the frictional force, lower the Coriolis force and speed. इतना clear है सबको? Very good. So that's it. Your frictional force story is also done. Now we write just 2 lines about सेंट्रीफ्यूगल एंड सेंट्रीपिटल फोर्स, तो वो भी लिख लेते हैं. हाँ जी बोलिए. लिस्निंग. हाँ करेंगे ना, आ रहा है. ठीक है अभी कर आते हैं कैंसिल यार, घबरा क्यों रहे हो, सब कराएंगे. ओके सो कम टू द नेक्स्ट थिंग. सो सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्सेस. यस डियर. Is a real force. Therefore, we have written the steering effect of the frictional force seems to be. क्या लिखा है हमने, है ना. स्टीयरिंग इफेक्ट ऑफ फ्रिक्शनल फोर्स सीम्स टू बी, हमको ऐसा लगता है कि वो कैंसिल कर रहा है, वो सिर्फ विंड को स्लो कर रहा है. ठीक है, बट हमको क्या लग रहा है कि वो विंड को स्लो करके कोरियोलिस फोर्स को अपोज करने का कोशिश कर रहा है. और कोरियोलिस फोर्स क्या कर रहा था, राइट में बेंड कर रहा था. तो अगर आप किसी राइट बेंडिंग फोर्स को अपोज करोगे तो आपको लेफ्टिस्ट बोल देंगे ना. नो पॉलिटिक्स, सिर्फ कोरियोलिस फोर्स. राइट है रॉन्ग है, आप लेफ्टिस्ट हो ना हो, आप बस अपोज कर रहे हो. ठीक है आप लोग समझदार है. ओके तो ओके शुड बी मूव बियॉन्ड, आगे बढ़े. ठीक है ये सब एपरेंट का गेम है. व्हाट सीम्स टू बी, लाइफ इज मोर अबाउट व्हाट सीम्स टू बी, पर्सपेक्टिव्स. लाइफ इज नेवर अबाउट रियलिटी, इट इज ऑल अबाउट, मोस्टली इट इज अबाउट परसेप्शन. हमारा सारा बिहेवियर परसेप्शन के ऊपर है, रियलिटी के ऊपर हमारा बिहेवियर होता ही नहीं है, क्योंकि रियलिटी हम में से बहुत कम ही लोग ढूंढते हैं. नहीं, हम तो सिर्फ परसेप्शन पे चलते रहते हैं ना. तो ये भी परसेप्शन है, ये दोनों ही परसेप्शन है. ठीक है, और रियलिटी समझने के लिए क्या करना पड़ेगा, अर्थ से दूर जाना पड़ेगा. स्पेस में बैठो, वहां से देखो कौन कौन क्या कर रहा है, सब दिखने लगेगा. So if you really want to understand the situation, go far from it. Don't involve into it. Then you will never understand it. अगर वो मेरी ग्राउंड का बच्चा बने रहोगे तो बॉल हमेशा बेंडी होता रहेगा. ठीक है आगे बढ़े. अभी भी डाउट है सर, आप बोलना क्या चाहते हो क्लियरली बोल दो. सर साफ साफ बोलो क्या बोलना है आपको. मैं आपको परसेप्शन और रियलिटी के बीच का गैप समझाने की कोशिश कर रहा हूं. एंड आई टोल्ड यू नेचर गिव्स यू ऑल एग्जांपल्स. दिस इज द ब्यूटी ऑफ नेचर. नेचर आपको इतना एग्जाम्पल देता है ना हर चीज का, दैट एट देयर विल कम अ स्टेज इन योर लाइफ व्हेन यू स्टार्ट रियलाइजिंग कि हमारा बिहेवियर कितना प्रिडिक्टेबल है, प्रोवाइडेड वी जस्ट लर्न फ्रॉम नेचर. एंड द रियल I should say unimaginable things are happening in nature. हम कुछ भी unimaginable नहीं करते हैं, हम सबका behavior pretty predictable है. Most of your polity, most of your economy, most of your social behavior is 100% predictable. That's why I have lost interest in it. क्योंकि वहां कुछ नया दिखता ही नहीं है. It is pretty predictable. Right? Where do you find new things, newer laws, newer rules? Nature में. Nature tells you those things. ठीक है, तो नेचर को जब आप देखना शुरू करोगे तो आपको खुद समझ में आने लगेगा कौन कौन सा, हाउ शुड वी एक्चुअली बी बिहेविंग. हमने बस कुछ चीजों को फॉलो करना शुरू किया. देयर आर लॉट मेनी मोर थिंग्स व्हिच वी कैन फॉलो एंड लर्न एंड मेक आवरसेल्फ मच मोर सस्टेनेबल. ठीक है, एनीवेज कम बैक. सो फ्रिक्शनल फोर्स हो गया, कोरियोलिस फोर्स एंड सेंट्रीपिटल फोर्स. इसके बारे में सेंट्रीपिटल फोर्स एंड सेंट्रीफ्यूगल फोर्स, लेट अस राइट अबाउट इट. So centripetal force, and so these two forces, once you have put that subheading right under it, they act only in case of rotating objects. The centripetal and centrifugal forces, they act only in case of rotating objects, where centripetal acts towards the center. Centripetal act toward the center, and centrifugal acts radially outwards. Radially outward. Centrifugal acts radially outward. And as these two cancel each other, the rotating object, as these two cancel each other, the rotating object neither moves away nor towards the center. Neither moves away nor towards the center. That is, it keeps moving in a circle. It keeps moving in a circle. Okay? So whenever you have a circular motion, there are two forces acting, centripetal and centrifugal, and they are cancelling each other. Then only you will get it. Otherwise, if one is more, if centrifugal is more, object will keep moving outward. If the centripetal is more, object will keep moving inward. Okay? But circular motion में ऐसा नहीं होता है. Is that okay? So in the case of these wind movements, they are generally cancelling each other. Therefore, we don't talk beyond it. Is that okay? ठीक है. अब क्या बचा? Anything else left? So that's it. These are your forces, right? All the forces which are acting on this. Now, what is left is, till now you have seen how winds behave when you have parallel isobars and only the pressure gradient force is acting. Now we will see after the break what happens when the isobars are not parallel and when other forces like frictional and Coriolis force are also acting. तो वो जब act करते हैं तो how do they affect the air movement? So till now you know the air movement for due to pressure gradient. Now we will see air movement due to Coriolis force and frictional force and pressure gradient when isobars are not parallel. ठीक है? But before that I'll give you a quick break. You take a break, come back, and then we start. Right? Hopefully no other doubts. Okay. So once we understand all these forces, please settle down. Okay. So next subheading is winds around circular isobars. We have seen till now winds around parallel isobar. अभी क्या देख रहे हैं? Winds around circular isobar. ठीक है? So let us come to this topic. Okay. So and you are now ready to understand this. So इसको कर लेते हैं. Then once we are done with this, then we'll move to winds on the surface of the earth. Okay. So when we talk of the winds around circular isobars, okay, so a circular isobar would be something like this, and then acha, before I just draw this, let me draw another thing for you. Suppose you have okay. So let us say you have two locations in India, one somewhere here, another somewhere here. Okay, and at these two locations, let us say one of them on the western side is warmer, so that is relatively low pressure. Okay, and the other one on the eastern side is high pressure because it is relatively cooler. हो सकता है, pretty much possible, होता ही है ऐसा. One place is hot, the other place is cold. Okay, and let us say all the places in between are accordingly warm and cold, right? So around this low pressure, right, and let us say around this low pressure the pressure is something like 960 millibars, कुछ ऐसा है, ठीक है, and around the high pressure the pressure is something like 1040 millibars, let us say. Okay, then around this low pressure, as you go in all directions, what should happen to the pressure? Let us say from the location A, if you go in surrounding it, so the pressure should 960 पे है already, so it should increase या decrease as you go from a low pressure region away from a low pressure region, the pressure should. So maybe you have a 970 location surrounding it. So the moment you get a 970 location surrounding it, you can connect all of them and make a what? Isobar. ऐसा एक isobar बना सकते हैं 970 का, है ना? And same thing you can do on that location also, 1040. As you go from a high pressure away from a high pressure in all directions, the pressure might decrease, and hence you can make a isobar around this region, let us say 1030, and so on. You can keep doing this. ऐसा? Yes or no? And you can have many more isobars in between, as many as you want, depending on what is the interval you are keeping. Interval reduce कर दो और ऐसा isobars बन जाएगा. So you have two locations having two set of circular isobars, है ना? Clear? Right? So two set of circular isobars. So do you understand how circular isobars are created? Circular isobar formation समझ में आया ना? You might have two different locations far from each other, and hence around them pressures might vary. Now see the other thing that I want you to show. See, let us say that I take only a small block of this diagram, itna sa, and I rub away all the remaining part, ठीक है, और hide away all the remaining part, बाकी सब कुछ को hide कर दिया. सब कुछ ही, what do you see? बचा क्या? पैरेलल आइसोबार्स, वहीं से स्टोरी स्टार्ट हुई थी. Yes or no? So do you understand how do we get parallel isobars? Parallel isobars are nothing but part of a bigger picture, right? And the bigger picture would generally be a non-parallel system, maybe circular or whatever. Okay, and when you just take a part of the diagram, it might look like a parallel isobar, and hopefully you can see here that one side you can write low pressure. इसमें लिख सकते हैं ना, एक साइड पे आप low pressure लिख सकते हो यहाँ पे, and the other side high pressure, and the wind you saw was moving from high to low, वो भी आपने देख लिया है. तो wind ऐसा move कर रहा है. तो अभी तक तो आपने ये समझा था, but now let us come to circular isobars. ठीक है? So if I try to take it back to the circular isobar वाला picture, ऐसा, right? Now if I ask you in this case how will the winds move? यहाँ पे wind कैसा move करेगा? क्या लगता है? Into the low. It will try to move into the low, something like this, and away from the high. If we are considering only the pressure gradient force, and which one of the winds did we take for our consideration? हमने बस ये वाला एक wind को ले लिया था. But basically the wind is moving at the low, into the low from all directions, and at the high, away from the high in all directions. Clear है? आ रहा है समझ में? But in this diagram also there is one limiting factor that we are taking. What? We are considering the effect of only pressure gradient force. हमने अभी Coriolis force और friction force का effect तो देखा नहीं. ठीक है? So now should we see the effect of friction force and Coriolis force also in this diagram, so as to understand how the wind will behave? Is that okay? So now, once we understand this, now I can take you to a point location. Okay, so let us say we have a point location, something like this, low pressure, and around the low pressure we have circular isobars, with the assumption that now you understand how circular isobars are formed. Okay, so you might have the circular isobar something like this, right? And now let us go on adding the effect of all the forces one by one and see what is the final outcome. Should we? तो अभी आंसर देने को आप तैयार हो? So now if I ask you before we start, what is the direction of pressure gradient force with respect to isobar? In what direction is the pressure gradient force with respect to isobar? Perpendicular. From which to which? High to low. So pressure gradient is always perpendicular to isobar from high to low. We know this. What is the direction of Coriolis force in the northern hemisphere? Right. What is the direction of frictional force in the northern hemisphere? Left. इतना तीन चीजें हमें याद रहेंगी. Right. And what is the wind direction? Wind direction will be in the direction of the resultant of all the three. जो भी उसका resultant है, wind वैसा जाएगा. ठीक है? So let us say take one by one all the pressures. So let us say we are in the northern hemisphere. ठीक है? Northern hemisphere. And let me first take the pressure gradient force. So let us say the pressure gradient force is in, obviously, तो यहाँ पे pressure gradient force का direction क्या होना चाहिए? Into or outward? Into. Pressure gradient force should be something like this. Is this okay? So this is your direction of pressure gradient force. ठीक है? And what is the direction of wind because of just pressure gradient force? If I say wind because of just pressure gradient force, suppose this is the wind. ठीक है? तो wind should also try to move. How? Inward. So the wind will try to move somewhat like this. Is this okay? यहाँ तक ठीक है? कितनों को नींद आ रही है यार? आप लोग ना रिएक्शन थोड़ा बिल्कुल डल होता जा रहा है. हाँ, सब ठीक है? पक्का? मतलब ऐसा तो नहीं बहुत ज्यादा हो गया आज सर, आज तो पता नहीं क्या क्या ही हो गया हमारा क्लास में. हाँ, क्या हुआ? कम अगेन? अच्छा, यू आर लिसनिंग टू मी इतना कॉन्सेंट्रेशन से. हे भगवान, आई एम अंडर हाई मोरल बर्डन. कुछ भी गलत बोला है ना, ऊपर वाला प्लीज बी विद मी. ओके, कुछ गलत ना निकले मुंह से, बच्चे सुन रहे हैं. ओके, ऑलराइट, गुड. बट हाँ, ऐसा नहीं लिसन करते करते सोना नहीं है ना. यस सर, वी वर लिसनिंग टू यू और इतना अच्छा सुनाया कि नींद ही आ गया. ठीक है ना. लोरी सुनते सुनते नींद आ जाता है ना, तो ये विंड का लोरी है. सर हवा भी बह रही थी, प्रेशर भी चेंज हो रहा था, हमें तो नींद ही आ गई. So alright, so good. So coming back, so do we understand the direction of the wind? Right, so wind will try to move in this direction. Now because this is northern hemisphere and wind is trying to move in this direction, which next force should we bring in? Coriolis force. Steering force लगाते हैं, देखते हैं क्या होता है. ठीक है? So when the Coriolis force will start acting in this, let us say the Coriolis force direction. So this one is showing the Coriolis force. ठीक है? Coriolis force. So what should be the direction of Coriolis force? Coriolis force acts Right to what? The pressure gradient force or no, right of the moving object? किसके? Right of the moving object, not the other force. Pressure gradient force, sorry, Coriolis force acts right of the moving object. ये ध्यान रखना है. Now, if you have not written this earlier, please do write. ठीक है? That the Coriolis force acts right of the moving object, not right of the pressure gradient. Because if it is right of the pressure gradient, then it will always be right of the pressure gradient only, and pressure gradient तो हमेशा एक ही direction में. ठीक है? So it is right of the moving object. And what is the moving object here? यहाँ पे moving object क्या है? Wind. ठीक है? So Coriolis force will act right of the wind here. ठीक है? For all your purposes, Coriolis force will act right of the wind. Is that okay? So what is the direction of the wind right now? Inward, and hence how should the pressure gradient, how should the Coriolis force act? कैसा? So we can say the Coriolis force will try to act like this. Do we agree? Coriolis force will try to act right of the wind, and because of this now the wind will also start to bend to the right. So the wind hence will start bending. ऐसा? This is the bending of the wind due to Coriolis force. ठीक है? कोई doubt? नहीं? Very good. Now just imagine that now that the wind has bent this much, यहाँ पे ऐसा, where will the Coriolis force now act? After the wind has slightly bent, where will the Coriolis force now act? It will perpendicular to the new wind direction or right of the new wind direction. ठीक है? So we can say as the pressure gradient keeps moving inward, the Coriolis force will now be acting somewhat like this. ये समझ में आया? So now the Coriolis force is acting effectively. What? Inward या outward? Outward. है ना? So effectively the Coriolis force will start acting outward. Right? And what is acting inward? Which force अभी तक? Pressure gradient force. So pressure gradient is moving inward and Coriolis is acting. So where will the wind go? ये तो centrifugal situation हो गया. Yes or no? And hence they will cancel each other. So where will the wind go? Inward. When the two forces cancel each other, where does the wind go? Is there a force pulling it inward? Net force pulling it inward? Net force pulling it outward? दोनों ही नो है क्योंकि दोनों कैंसिल हो गया. So will the wind stop or will it keep moving? It will keep moving. But where? Circular. It will neither go away nor come out. Sorry. So neither go away nor go in. So where will the wind move? Resultant to these two. Huh? Resultant to these two. How will the wind move? Can you see? So I would like you to write also. अब ये लिखना भी है. ठीक है? Name of the force and direction of wind movement. लिख लें? ठीक है? So force and wind direction or movement. So if we talk of pressure gradient force, how is the wind moving? Radially. So just pressure gradient force moves the wind radially inward. Right? And PGF and Coriolis force resultant makes it move what? अभी आपने सीखा दूसरा वाला पार्ट, हाउ इनवर्ड और आउटवर्ड और सर्कुलर. बिकॉज ऑफ बोथ ऑफ देम इट इज मूविंग हाउ सर्कुलर. ये ऊपर अभी देखा ना हमने, द विंड इज मूविंग सर्कुलर बिकॉज इट इज नीदर एबल टू गो इन नॉर एबल टू गो आउट, सो इट गोज सर्कुलर. ठीक है. एंड इफ आई आस्क यू इन द नॉर्दर्न हेमिस्फीयर व्हाट इज द डायरेक्शन ऑफ द सर्कल मोशन, क्लॉकवाइज एंटी क्लॉकवाइज. नॉर्दर्न हेमिस्फीयर में ये इज इट क्लॉकवाइज और एंटी क्लॉकवाइज? एंटी क्लॉकवाइज. तो वो भी लिखना है आपको, सर्कुलर एंटी क्लॉकवाइज वेयर इन नॉर्दर्न हेमिस्फीयर, सर्कुलर एंटी क्लॉकवाइज इन नॉर्दर्न हेमिस्फीयर. इज दिस ओके? नाउ शुड वी अप्लाई द थर्ड फोर्स? तीसरा फोर्स कौन सा है? फ्रिक्शनल फोर्स. ठीक है. सो what is the effect of frictional force? Now if these two forces are moving like this, now if I draw the same diagram slightly neat here, ठीक है. So basically your wind is moving something like this. I'm directly drawing that circular motion. The wind is moving like this and the pressure gradient force is moving radially inwards. Do we agree? यही आपने बताया मुझे. And how is the Coriolis force acting? Coriolis force is acting outwards. That's exactly why the wind is moving circular. ठीक है ना, कैंसिल हो गया एक दूसरे से. Now which is the new force you have to bring into play? Frictional force. And what is the direction of frictional force? Opposite to. And what is the direction of Coriolis force? So what should be the direction of frictional force in a low pressure region? Inward. तो ये रहा आपका. Let me use a different lightish color. So this is your frictional force. दिख रहा है? Can all of you see this frictional force? So frictional force will be inward or outward? So frictional force will act inward, hence it will assist the already existing pressure gradient force. ठीक है? Right? So it will just assist the pressure gradient force. Why? Because it has to oppose the frictional force. ठीक है ना? So now how many force inward and how many force outward? So net force is inward. So this circular motion will now try to do what? It will try to do circular motion inward. Circular motion inward का क्या मतलब है? Please see. If this circular motion has to happen inward, it simply means, please see, suppose the circle starts from here. The circle will become shorter by the time it reaches back. है ना, तभी हम बोलते हैं ना इनवर्ड. तो सर्कल जब अपना एक सर्कल पूरा करके आएगा, it will become shorter than the circle, and then when it will go to do the second circle. ठीक है, तो सेकंड सर्कल कैसा होगा? वो भी शॉर्टर. ठीक है, वो थोड़ा ज्यादा शॉर्ट हो गया सडनली. ठीक है, एंड थर्ड सर्कल अगेन शॉर्टर, एंड नेक्स्ट सर्कल अगेन शॉर्टर. तो ये शॉर्ट होता होता, व्हाट डू यू कॉल दिस मोशन? स्पाइरल. है ना, कैन यू सी? सो विंड फाइनली मूव्स स्पाइरल. इनवर्ड और आउटवर्ड? ड्यू टू विच फोर्स? So what makes the wind move radial? If I ask you, which force? Radial. आपका कॉपी में लिखा हुआ है, ध्यान से देखो. Pressure gradient force. Which forces make the wind move circular? Pressure gradient and Coriolis force. And which forces or which force finally makes the wind move spiral? Frictional force and Coriolis force in addition to pressure gradient force. When all the three act, we finally get spiral. RS1 में. So this is your, and what direction is this spiral? Inward. तो low pressure तो था ही, which we already knew. And which hemisphere? Northern hemisphere. Low pressure. Spiraling direction, clockwise, anti-clockwise. Spiral, inward, anti-clockwise. ठीक है? Is this okay? So if we have to write यहाँ पे, when the pressure gradient force and Coriolis force and frictional force together give you what motion? Spiral. Again anti-clockwise. In northern hemisphere. और ये जो आपने लिखा है pressure gradient force makes it move radially inward, that is for which pressure? Low pressure. For low pressure it will move radially inward. For high pressure it will move radially outward. आ गया समझ में? Is this okay? Clear? So do you understand now finally what is the final effect of all the three forces? Spiral inward if it is a low pressure. Spiral inward if it is a low pressure. And spiral outward if it is a high pressure. Is that okay? Anti-clockwise, clockwise वो सब hemisphere specific है. उस पे हमें नहीं जाना है अभी. ठीक है? So what can we write? Hence, low pressure gives you spiral inward and high pressure gives you spiral outward. Low pressure gives us spiral inward and high pressure gives us spiral outward. इतना clear है? पक्का? इसमें confusion तो नहीं होगा? पक्का ना? Very good. So now let us make the final chart. Should we? So what did we learn? Low pressure will give you spiral and high pressure will give you spiral outward. Okay? And northern hemisphere and southern hemisphere. दोनों में हमें देखना है. ठीक है? Right? So LP is inward and HP is outward. पहले तो ये लिख लेना है so that you are clear. ठीक है? कि कौन सा हेमिस्फीयर में कैसा होगा. Alright? So low pressure inward, ये दोनों डायग्राम inward होगा and high pressure outward, ये दोनों डायग्राम outward होगा. Clear? Alright, now the second thing, if I take this one, so here you have a low pressure inward and northern hemisphere, it should be clockwise or anti-clockwise? क्या पढ़ा है हमने? Anti-clockwise. Now one more thing I want you to write before you go further is, low pressure movements are also known as cyclonic movements. Cyclonic, इनको हम cyclonic movements भी बोलते हैं, low pressure को. And high pressure movements are also called as anti-cyclonic movements. Anti-cyclonic movements. So low pressure are called as cyclonic movement and high pressure are always called as anti-cyclonic movement. Outward moving wind, anti-cyclonic. Inward moving wind, cyclonic. Clear है? ठीक है? So in the northern hemisphere, the cyclonic wind will be anti-clockwise, anti-clockwise and so इसको कैसे बनाएंगे? Anti-clockwise inward, है ना? So just start from out and go on drawing spiraling inward. तो कैसे डायग्राम बनेगा? Start from out and go spiraling inward anti-clockwise, ऐसा बन गया. ठीक है, स्टार्ट फ्रॉम आउट एंड मूव योर हैंड एंटी क्लॉकवाइज इनवर्ड, यू विल गेट इट, और कुछ नहीं करना है, राइट. सो स्टार्ट फ्रॉम आउट एंड स्टार्ट गोइंग इनवर्ड एंटी क्लॉकवाइज, दैट्स इट. अब ये क्लियर होना चाहिए कि एंटी क्लॉकवाइज हाथ कैसा घुमाते हैं, इनवर्ड कैसे जाना है. अब ये भी मुझे बोलोगे तो थोड़ा मुश्किल हो जाएगा आकर के बताना, ठीक है. क्लियर. So something like this you should get, something like this, anti-clockwise and inward. और ये बहुत केयरफुली बनाना है, बिकॉज आई हैव फाउंड मेनी टाइम्स यू पीपल ड्रॉ इट रॉन्ग, और रॉन्ग बना के एकदम खुशी से बैठे रहते हैं हंसता हुआ. So once you have drawn, put your pencil tip on the outside and see आपका एरो डायरेक्शन में गया तो इनवर्ड जा रहा है कि नहीं जा रहा है, और एंटी क्लॉकवाइज जा रहा है कि नहीं जा रहा है, दोनों चीज चेक करना है. ठीक है, हो गया. ओके, नाउ द सेम लो प्रेशर इन द सदर्न हेमिस्फीयर, व्हाट शुड बी द डायरेक्शन? फर्स्ट ऑफ ऑल, शुड इट बी इनवर्ड और आउटवर्ड? लो प्रेशर, लो प्रेशर इज ऑलवेज इनवर्ड इररिस्पेक्टिव ऑफ हेमिस्फीयर. उससे हम इसीलिए ऊपर ही लिख दिया हमने, लो प्रेशर इनवर्ड एंड साइक्लोनिक. ठीक है, बट इन द सदर्न हेमिस्फीयर द डायरेक्शन विल चेंज. सो इनवर्ड तो रहेगा, बट क्या चेंज हो सकता है? एंटी क्लॉकवाइज टू क्लॉकवाइज. सो नाउ यू हैव टू मूव योर पेंसिल फ्रॉम आउट क्लॉकवाइज इनवर्ड्स डायग्राम में. ठीक है, तो बाहर से बनाना शुरू करिए एंड गो क्लॉकवाइज इनवर्ड, ऐसा. ठीक है, एंड आई कैन सी बहुत सारे लोग कॉपी के अंदर पक्का नहीं है हाथ किधर घुमाना है. ठीक है, तो अभी थोड़ा ध्यान से करना, गड़बड़ नहीं होना चाहिए. आई वोंट कम टू चेक योर कॉपी. और साथ वाला थोड़ा ध्यान से देखो कि बाजू अपना बनाने के बाद, पहले नहीं, पहले अपना बनाओ फिर साथ वाले का कॉपी में देखो कि सही है या गलत है. कितनों का साथ वाले का डायग्राम गलत है? इनका गलत है, आप इनका देखो सही है. सही है इनका, तो आपका अपना गलत है. तो मान गया, विश्वास हो गया. चलो आप भी चेक कर लो यार, ये ना हो दोनों मिलकर के उस बेचारे का नैया डुबा देना. हाँ, सो प्लीज क्रॉस चेक, अपना साथ साथ वालों का डायग्राम चेक कर लो यार, अनटिल अनलेस कंपटीशन रियल टाइट हो. इसका तो गलत ही है तो अच्छा है. होता है ना. ठीक है, एवरीवन परफेक्टली फाइन. ठीक है, वेरी गुड. नाउ लेट अस कम टू हाई प्रेशर. हो गया, वेरी गुड वेरी गुड. कम बैक. सो इन हाई प्रेशर, in the high pressure, how does the wind move? Inward or outward? Outward. And what do we call high pressure situations as? Anti-cyclonic. So high pressure को हम बोलते हैं anti-cyclonic. Keep that in mind. ठीक है? So outward, right? And we call it as anti-cyclonic. अब इसका wind direction कैसा होना चाहिए? If cyclonic is anti-clockwise, now please listen. Northern hemisphere, I'm just talking of one, and then you have to apply logic. You could draw also, घर जाके बना भी सकते हैं. I don't want to, मैं थोड़ा थक गया हूँ, मूड नहीं है. चलो ठीक है, ठीक है. Right, so what do you get? If in the northern hemisphere cyclonic is anti-clockwise, anti-cyclonic should be clockwise, and outward, तो outward clockwise. Do we agree? Anti-cyclonic should be outward क्लॉकवाइज. क्या याद रखना है? आउटवर्ड क्लॉकवाइज. अब अपना हाथ वैसा घुमाओ पहले हवा में, आउटवर्ड क्लॉकवाइज कैसा घूमना है. तो सेंटर से स्टार्ट होंगे एंड देन यू गो आउटवर्ड, मूविंग क्लॉकवाइज. इज दैट ओके? सेंटर से स्टार्ट होना है, बाहर से नहीं. स्टार्ट फ्रॉम सेंटर एंड गो आउटवर्ड क्लॉकवाइज एंड ड्रॉ इट. आउटवर्ड एंड क्लॉकवाइज. बन गया? आई नो प्रिटी डिफिकल्ट. ऐसा ही लाइफ ऐसा ही गोल गोल घूम रहा है. ठीक है, वैसे समझ में नहीं आता सर, ये विंड भी वैसे ही घूमने लग गया. हाँ जी. सो व्हाट यू हैव टू चेक इज फाइनली यू आर मूविंग फ्रॉम द सेंटर आउटवर्ड एंड क्लॉकवाइज. If your diagram is going outward and clockwise, you are right. ठीक है, for northern hemisphere, high anti-cyclonic condition. ये बना लिया, right? Everyone is getting this diagram. Your neighbors are also getting this diagram. हाँ, everyone, perfectly fine. तो अभी last वाला बना लेते हैं. In the end, what should I get? And the logics are same. You can just apply the same diagram जैसा हमने forces लगाया है और बना सकते हैं. हाँ, बोलो बोलो, कोई बात नहीं, उससे नहीं घबराना है. क्या चीज? नॉर्दर्न हेमिस्फीयर में एंटी क्लॉकवाइज क्या चीज बताया? लो प्रेशर. तो हाई प्रेशर में क्या होना चाहिए? आ गया समझ में? पक्का? यही मैं चाहता था. यही छोटा मोटा गड़बड़ हम कर सकते हैं. So is this okay? Right. So now come to the last one. Southern hemisphere, high pressure. What should it be? Inward or outward? First of all. Outward तो हमेशा ही रहेगा ना. High pressure है तो outward ही है. And this time, because northern hemisphere was clockwise, so this one should be anti-clockwise. So outward, anti-clockwise. अब मुझे नहीं पता क्योंकि मैं आपको उल्टा देख रहा हूँ. ठीक है, तो आप अगर मुझे ऐसे ऐसे करके बताओगे तो मेरा भी दिमाग घूम जाता है उधर से. ठीक है, तो खुद सोचना है. एंटी क्लॉकवाइज आपको पता होना चाहिए और आउटवर्ड कैसे जाना है वो भी पता होना चाहिए. ठीक है, done everyone, all the 4 diagrams. Now please check only for northern hemisphere and please see and tell me cyclonic is moving. Cyclonic हमेशा ये याद रहेगा. cyclonic means low pressure means inward or outward. ये तो आपको सिंपल चीज पहले ही पता है because wind moves always towards in low pressure and away from high pressure. तो ये तो हमको बेसिक रूल पता है ना. So low pressure means cyclonic means low pressure, so wind will always move inward, and in northern hemisphere it is moving anti-clockwise. So cyclonic in the northern hemisphere is moving anti-clockwise and anti-cyclonic in the northern hemisphere is moving. So anti साथ नहीं है, ऐसे ही याद रखना है. ठीक है, you have to remember only for northern hemisphere. In northern hemisphere cyclonic will always be anti-clockwise and anti-cyclonic will always be. बस इतना याद रख लो. ठीक है, और हाई लो आपको खुद पता होना चाहिए. अब वो गड़बड़ किया तो मेरा जिम्मेदारी नहीं है. ठीक है, cyclonic means low pressure and anti-cyclonic means high pressure. And northern hemisphere cyclonic anti-clockwise, anti-cyclonic clockwise. So anti will not pair together. दो एंटी साथ मिला दिया तो गड़बड़ हो जाता है. ठीक है, so good enough. So this is how you remember and hopefully now you are clear. तो अभी आगे बढ़ जाए. So circular motions are clear to everyone, can I assume? Yes? Doubt? Anyone has a doubt? आपका कोई डाउट है? लास्ट नहीं, ऐसा ही अंगड़ाई ले रहे सर. हो गया बहुत कुछ आज के लिए. ओके, वेरी गुड. नो डाउट. So should we move beyond? Yes or no? Very good. So you have understood a major part. आपको cyclonic movement समझ में आ गया. ठीक है, so how will the cyclonic wind movements take place? You have understood. Now one last thing that I want you to write around that diagram, maybe not on that diagram, is a low pressure condition. Low pressure condition based on its intensity. Based on its intensity, a low pressure condition is known as low, then depression, right? First we call it as low and then depression and then finally cyclonic. ऐसा बोलते हैं. सबसे पहले क्या बोलेंगे? Based on its intensity. So if the intensity is less, we'll call it as low, and where the intensity is maximum, there we'll call it as cyclonic, and if the intensity is in between, you call it as depression. So how strong is the low? If it is a weak low, low. If it is a moderate low, depression. If it is a strong low, cyclone. ठीक है, तो ये सब एक ही चीज है. लो, डिप्रेशन, साइक्लोन, दे आर ऑल टाइप्स ऑफ लो प्रेशर कंडीशन. ओनली देयर इंटेंसिटीज वेरी. ऑलराइट, वेरी गुड. So once we understand this, now let us come to air movement on the earth. So wind movements on earth. Should we do it? Wind movement on earth. Wind movement on earth. Okay. So let us draw the earth. थोड़ा ऐसा earth का part बना लेते हैं. And we are drawing just the pole and the equator. So this is pole, this is equator. Right? And we are just drawing a part of the earth, not the whole earth. So itna part of the earth bana hai. And this is the center of earth. Pole, earth, equator and center of the earth. साथ साथ बनाना भी है. And I will also draw the tropopause. So suppose this is the tropopause. And that's the surface of earth. Okay. Now, which region should be a warmer region and which region should be colder region between pole and equator? इतना पता है सबको? ठीक है. So pole should be colder and the equator will be. So pole का पास bluish color बना दीजिए, that is cold, and equator का पास reddish color, warm. ठीक है. And if you feel like, you can also write cold and warm for your own sake. Colder, warmer. So you are trying to show that the surface is colder and warmer in these two regions. ठीक है. So if the surface is colder and warmer like this, let us start with equator. And you can see the tropopause also in that. So on the surface, what type of pressure should I get near the equator? High pressure or low pressure? Low pressure. So at this region I will get a low pressure. And how do the winds move at low pressure? Horizontally. Horizontally. आपको कॉपी में चेक करना है, ऐसा ही कुछ भी बोलना नहीं है क्लास में. Horizontally and vertically outward. Everyone agrees? ठीक है. So I am drawing two winds. आपको बताना है कौन सा इनवर्ड होगा, कौन सा आउटवर्ड होगा. You have said horizontally inward and vertically outward, right? So this is wind number 1 and this is wind number 2. So which one should be inward? One will be, inward या 2? Inward कौन सा होगा? 1 या 2? How many of you think 2? How many of you think 1? पूरा हाथ खड़ा नहीं है, बहुत ही कम लोगों का है. ये बाकियों का क्या स्टेटस है? सर वी आर नॉट थिंकिंग राइट नाउ बिकॉज आई हर्ड 2. किसी ने तो 2 बोला था. सिर्फ मेरा कान बज रहा था या 2 सही में बोला था? किसी ने बोला था? किसी ने? डू यू पीपल अग्री? है ना. ऐसा तो नहीं कि सर आपका एज हो गया, आपको कुछ कुछ सुनाई देता रहता है आजकल. हाँ. सो एनीवन स्टिल होल्डिंग ऑन टू 2? सब अग्री करता है 1? Okay, so 1 is what? And 2 is outward. पक्का? यार अपना आवाज दबाना नहीं है क्लास में. You know, यहाँ पे लॉजिक चलता है. ऐसा नहीं कि सारे साथ वाले बोल रहे हैं, अगर हमने कुछ बोला तो गड़बड़ हो जाएगा. So if you don't understand, raise your hand right now. बाद में मौका नहीं मिलेगा, क्योंकि आपको कुछ समझ में नहीं आएगा इसके बाद. हॉरिजॉन्टल, बिल्कुल perfectly fine, बट इसमें हॉरिजॉन्टल है कौन सा? उसके लिए आपको इस अर्थ के ऊपर खड़ा होना पड़ेगा। अभी समझ में आया? अर्थ खड़ा कैसे हो गए? खड़ा करके दिखाऊं? आप लोग का क्लास में पिछली बार खड़ा किया था ना ऐसे ही डायग्राम में, याद है ना? यही प्रॉब्लम है। देखो मैं इसीलिए बोल रहा था, मुझे पता है किसी कोई ना कोई मन की आवाज दबा के बैठा है, वो अपने मन की बात कर नहीं रहा है, ठीक है, जबकि मन का बात होना चाहिए क्लियरली। ठीक है, अभी क्लियर है? ठीक है। सो ओके, सो 1 horizontally inward and 2 outward. Clear? Very good. So now, so this way you get this, and then in the upper atmosphere near tropopause क्या होना चाहिए? Opposite mechanical. So this low is created thermally or mechanically? This is a thermally created low. वो साथ साथ लिखते रहना है. On the equator we get a, on the surface of the earth we get a thermally created low. Okay, thermally created low. And in the upper atmosphere what should I get? Upper atmosphere में क्या बनेगा? यहाँ पे wind is moving vertically, this region wind is moving vertically inward, and horizontally it will try to go, horizontally it will try to go outward, ऐसा है ना? So this is what pressure condition? It is like a high pressure condition created mechanically or thermally. This is high pressure mechanical. वो साथ साथ लिखते रहना है, mechanical thermal. ठीक है? So this, right? Now let us go to the pole. तो पोल के ऊपर क्या मिलेगा? What will we get at the pole? How should the wind move? Vertically? हाँ? High pressure? Vertically? अच्छा ऐसा बोलो, ये कोल्ड है, कोल्ड मतलब प्रेशर, हाई प्रेशर, सो हाई प्रेशर पे वर्टिकली, तो आउटवर्ड क्यों बोला? हॉरिजॉन्टल के लिए पहला ही बोल दिया, अच्छा ठीक है चलो कोई बात नहीं। सो हॉरिजॉन्टली आउटवर्ड एंड वर्टिकली इनवर्ड, बच गए इस बार, ठीक है। सो वर्टिकली इनवर्ड एंड हॉरिजॉन्टली आउटवर्ड, परफेक्टली फाइन। And in the upper atmosphere, what should I get? Huh? And this high pressure is thermal or mechanical? ये high pressure heating cooling की वजह से, तो वो तो thermal है। Mechanical means motion का वजह से, because of motion. So this is due to motion or due to heating cooling? So this is a thermally created high pressure. All right. And in the upper atmosphere, we get a low pressure created mechanical. Why? Because the wind is just descending. तो वहां पे something like this. All right. Now, if you integrate the whole image, what do you get? That on the surface of the earth, the wind is moving from which region to which region? Pole to equator. So on the surface, the wind is trying to move from somewhat from pole to equator. I'll put a few dots in between. ऐसा, ठीक है। And on the in the upper atmosphere, the wind is moving from equator to pole, ऐसा, ठीक है। Is that okay? Now, which forces we have not taken into consideration? And if Coriolis force we are not taking here, then what is the status of the earth? Is it rotating or not rotating? So this would be the wind if the earth was not rotating. If the earth was not rotating, therefore no Coriolis force, then only you will get this wind. ठीक है? So this is wind movement on earth. What type of earth? Non-rotating earth. वो लिखना है यहाँ पे. For non-rotating earth. For non-rotating earth. All right? Clear? Only if the earth is not rotating, then no Coriolis force, so no bending left and right, and hence you will get winds moving like this. Clear? But in reality, the earth is rotating. So now we have to understand wind movement on rotating earth. ठीक है, तो ये हो गया. इसका बाद ड्रॉ करिए. विंड मूवमेंट ऑन रोटेटिंग अर्थ. Rotating earth means effect of Coriolis force and frictional force also we will take into play. ठीक है, all right. So under this, the first thing that we'll do before we do the earth's winds on the earth surface, I hope this much is clear to everyone. यहाँ तक तो सबको clear ही है. Which means if I ask you on the earth, even if the earth was rotating in the upper atmosphere, the wind will try to move from where to where? Equator to pole, and then it will try to bend and all. वो सब देखते हैं अभी. But in the upper atmosphere, the wind will be moving from equator to pole. Do we agree? ये चीज थोड़ा ध्यान रखना है, अभी याद में रखना है. What? That in the upper atmosphere, due to pressure gradient, the wind tries to move from equator to pole. Is this okay? Now, let us put a subheading here, geostrophic winds. Geostrophic winds. Why? Because to understand the movement of air on rotating earth, you have to understand geostrophic winds. Okay, geostrophic winds are necessary to understand for understanding rotating earth winds. Okay, and this topic is given in your NCERT. एक छोटा सा बॉक्स बना हुआ है, geostrophic winds. How many of you have seen? देखा है थोड़ा कहीं, है ना? तो वहाँ पे एक बॉक्स बना है. They do explain, but first let us do it in the class and then we move on. So what is geostrophic winds? You write below this. To understand the wind movement on a rotating earth, to understand the wind movements on a rotating earth, we need to first understand geostrophic winds. We need to first understand geostrophic winds, which are upper atmospheric winds, within bracket, upper atmospheric winds, bracket start, just below the tropopause, bracket close. ठीक है, and put a full stop. So let us understand what are geostrophic winds. पहला वो समझते हैं, then we'll go to this thing. Okay, should we? Right? So now please see and please do draw along with me. मेरे साथ साथ कोशिश करो बनाने का भी. So this time I am drawing the globe, not half but full globe. ठीक है? And this whole line is equator, and this point is pole. All right, and broadly that's it. अभी इतना चाहिए. And we will be drawing winds of upper atmosphere only. Drawing winds of upper atmosphere only. Drawing the winds of upper atmosphere only. ठीक है? So in this diagram we will not draw any surface wind. So surface factors नहीं लेने हैं. Only upper atmosphere factors we will take. Drawing the winds of upper atmosphere only. Is that okay? So now if I ask you what kind of pressure in the upper atmosphere do we have? Above equator. Equator के ऊपर कौन सा pressure है? High. And above pole? Low. So the direction of pressure difference is from equator to pole. So pressure gradient force direction will also be equator to pole. Do we agree? So if I add the pressure gradient force here, red color, PGF, I hope everyone understands the direction of PGF will be something like this. In the upper atmosphere, that's why we have written all the directions are for, all the drawings are only for अपर एटमॉस्फेयर, ठीक है, हम सरफेस का बात ही नहीं कर रहे हैं यहाँ पे. सो इन द अपर एटमॉस्फेयर दिस रीजन हैज अ लो प्रेशर, वो सॉरी हाई प्रेशर, वो लिख लेना है, हाई प्रेशर, एंड द पोल विल हैव low pressure, and the direction of pressure gradient is high pressure to low pressure. Okay, now let me add the direction of winds also to this. ठीक है, तो ये wind है, gray color, right? So from the equator the wind will start to blow, and in what direction will it blow? From equator to pole. So the winds will also start to blow like this. Hope everyone understands. Now what is the Coriolis force above equator? 0. So starting mein there is no Coriolis force and the wind will keep moving towards pole. But when the wind moves slightly away from the pole, sorry, when the wind moves slightly away from equator, which force will start becoming strong? Coriolis force. And in what direction does the Coriolis force apply? Right in northern hemisphere. Right to what? राइट टू द विंड. वही वाला वो सर्कुलर मोशन टाइप का कहानी हो रहा है यहाँ पे भी. सो नाउ लेट मी ऐड द कोरियोलिस फोर्स. सो कोरियोलिस फोर्स विल स्टार्ट एक्टिंग. इट विल बी लेस इंटेंसिटी, right? It initially it will not be high intensity, low intensity, okay, and it will start acting right of the wind, ऐसा. So now what will be the wind direction? Thanks to this, wind will tend to bend toward the east. Very good online people, right? हंस क्यों रहे हो यार, मतलब ऐसा थोड़ी दूसरे का, right? I'm seeing those answers coming, so I have to tell them also they are writing the right answers. Perfectly fine. Okay. So the wind will bend this way, but as the wind bends, still it is moving away from equator. So which force will go on becoming stronger and stronger gradually? And Coriolis force will go on acting also. What? Right to the wind. So ये ऐसा bend हो गया अब. Can you see? Like this. And ultimately further the wind will further bend thanks to this. तो wind अब आगे जाके ऐसा हो जाएगा, more bent. और उसके ऊपर और फिर से कोरियोलिस फोर्स डाल दो. So ultimately what will happen to the wind direction? If I use a thicker gray color stroke, the wind will finally become something like this. Yes or no? Why? Which two forces will become equal and opposite? Pressure gradient force towards the pole, ठीक है, and Coriolis force opposite to it. So pressure gradient and Coriolis force will become equal and opposite to each other. ठीक है. So now this wind will go neither polewards nor equatorwards. Yes or no? This wind will go neither poleward nor equatorward. So अब कहाँ जाएगा वो? Can it go northward? No. Why? Because that is poleward. Can it go equatorward? No. Why? Because that is the Coriolis force का direction, right? So it can't go equatorward nor can it go. So where will it go? It will start moving west to east. आ रहे समझ में? So this wind starts to move west to east. Now some of you might think, sir, where is the frictional force? है ना? हमारा हीरो कब कूदेगा बीच में, राइट? बट हीरो का कैरेक्टर होता है, वो सिर्फ ग्राउंड के ऊपर एक्ट करता है, ऊपर नहीं. है ना? कभी देखा है सुपरमैन ज्यादातर फिल्म ऊपर ऊपर ही गुजार दे? वो ज्यादातर नीचे ही रहता है, ऊपर को ज्यादा काम है नहीं. सिंपली सेड, देयर इज नो फ्रिक्शन इन द अपर एटमॉस्फेयर. है ना? तो जब फ्रिक्शन ही नहीं होगा तो फ्रिक्शनल फोर्स किधर से होगा? फ्रिक्शन इन द अपर एटमॉस्फेयर इज ऑलमोस्ट एब्सेंट, hence the frictional force is also almost absent. So friction force will never come into play. Hence, if it is not coming into play, now please see this. The wind was going initially like this. Now if you see like this, this is the outer circle and this is the center. Pole is the center and this is the equator. Now as the wind tries to go like this, aisa, it will keep bending and then it will turn like this and then it will keep going like this. So if I draw from here, the wind is going like this, aisa. It is neither going toward the center nor going outward. यही तो आपने सीखा था अभी. Circular, when just two forces act, the wind moves circular. तो यहां पे भी तो वो circular ही move कर रहा है ना, around the earth. Imaginable, ठीक है? And because there is no frictional force, so it will neither go inward nor go outward, right? So in the upper atmosphere, this wind will keep moving circular around the earth, west to east, ऐसा. Can you imagine? ठीक है? This circular moving wind around the earth is known as geostrophic wind. इसी wind का नाम है geostrophic wind. Is this clear? ठीक है? So can I write? ठीक है? कोई डाउट है तो पूछो, बिना घबराए पूछो यार, कोई बात नहीं. Yes? Nothing? Sir, sir, that's why we call easterlies. Easterlies अभी आ रहा है, Prince. This is not easterlies, this is something else. We'll come to easterlies in a while. Yes? Nothing? Everyone is clear? पक्का? इतना जल्दी हो गया? हाँ, unbelievable. पक्का? Very good. All of you. So should we write? अब तो मेरा काम complete है फिर. Write down. Okay, as we see, initially there is a high pressure in upper atmosphere, above equator, high pressure upper atmosphere above equator, and low pressure upper atmosphere above pole. Low pressure upper atmosphere above pole. Hence PGF in upper atmosphere. PGF in upper atmosphere is from what to what? PGF in upper atmosphere is from equator to pole. Therefore, upper atmosphere wind starts to move from equator to pole. Full stop. Okay. Gradually, as we move away from equator, the Coriolis force starts to increase from zero, and in the northern hemisphere it tends to bend this poleward moving air it tends to bend this poleward moving air towards the right. Towards the right. Full stop. Hence, as this upper atmosphere air, as this upper atmosphere wind, hence as this upper atmosphere wind continues to gradually keep moving right, it becomes equal and opposite. It becomes equal and opposite to the pressure gradient force, in such a manner that now the upper atmosphere wind has a zero resultant force. Upper atmosphere wind has a zero resultant force poleward or equatorward. Zero resultant force poleward or equatorward. And now it continues to move. Now it continues to move in a west to east direction. In a west to east direction, going circular around the earth. Going circular around the earth, as shown. Moving in the upper atmosphere. Moving in the upper atmosphere and known as geostrophic winds. ठीक है? Geostrophic winds. Also, we will have such winds in both hemispheres. We will have such winds in both hemispheres, and in both they will move west to east. And in both they will move west to east. Both they will move west to east, as the bending in southern hemisphere is leftward. ठीक है? Bending in southern hemisphere is leftward. Just imagine two friends moving in opposite direction. ऐसा जा रहा है, एक northward जा रहा है, एक southward जा रहा है, right? And you tell one to move right and the other to move left. ठीक है? So the one who's going like this and the one who's going like this, you ask both. This one you ask move right, this one you ask move left. दोनों एक ही तरफ bend हुए ना? That's it. So in both the hemisphere the wind will move west to east only. Clear? So with this the geostrophic wind is over. Next class which we have tomorrow. Very good. So tomorrow we start with the remaining part of this wind and continue. Alright. So please read GC Leong and NCRT. Online people, I don't see any major doubts. Ma'am, is there anything you want me to take up? Nothing. So that's it. Online people, everyone, thank you. No major doubts. Thank you.